Hello and welcome everyone to GraphQL Enterprise Connect, presented by This.Media, PayPal, and Braintree. Thank you all for joining us today.
So we have a really exciting schedule today. We're going to start off here with an introduction and a keynote panel. Then we're going to be going in and talking about some really interesting topics related to GraphQL. This is also on the website graphqlenterprise.com. So if you ever have a question, about the schedule, feel free to check there. It's also in the description of this YouTube live stream. So we hope you get to join us for all of them, especially the community panel that's also going to happen right after lunch.
Awesome. It's a great day full of great talks. This.Media would like to thank our co-hosts PayPal and Braintree. I'd like to introduce Mark Stewart, Senior Engineer Manager at PayPal.
Hey everyone, I lead the checkout integrations team at PayPal. I wanted to start off by saying, welcome. The idea for this conference actually sprung up as we were looking around at all the conference circuit, but we couldn't really find anything that focused on real life GraphQL problems at large companies. So hopefully you'll enjoy the content today. Thanks to our sponsors, so PayPal, Braintree, Fauna, OneGraph, React.js Boston, and Seattle React. For the sponsor bit for PayPal, wanted to mention that PayPal and Braintree has over 80 job openings that work with GraphQL. The positions range from full stack web developers, backend API and mobile developers. In the US, most of these openings are actually open to remote workers. And we also have job openings in Bangalore and Guatemala City. So that's it for my sponsored bit from PayPal. Hope you all have fun today. I encourage you to get to know each other, use the chat features, ask questions and Q&A, and have fun. Thanks.
Thank you, Mark. Also, we'd like to give a huge thank you to our sponsor, Fauna, and our community partners, Modern Web Meetup, OneGraph, Seattle React Meetup, GraphQL Texas, Golden Gate GraphQL, and React.js Boston Meetup.
Yes, there is a local meetup literally everywhere you go, and a lot of them are doing online meetups right now, so definitely check those out. We also have GraphQL Meetup, so if you go to graphql-meetup.com, you'll see some amazing events that we have every month. A lot of them partnered with Eve of Moon Highway, so.
Awesome. We're kicking off today's event with our keynote panel. I'm pleased to introduce our MC for today, Shruti Kapoor, software engineer at PayPal, GraphQL React and JS developer, and dev joke connoisseur. Welcome, Shruti.
Hey, everyone. Thank you so much for having me this dot. I am so excited to be here. Welcome to this exciting times of virtual conferencing in the otherwise monotonous year that is 2020. We're so happy you are able to join us, and welcome to the GraphQL Enterprise Connect hosted by PayPal, Braintree, and this dot. I want to start off by a little bit of intro about myself. I'm Shruti Kapoor. I'm a senior software engineer at PayPal. I will be your MC today. I've been working at PayPal for over 2 years now, and I've been working with GraphQL for almost 2 years as well. At PayPal, I've been working with GraphQL for almost 3 years. We started with one team and slowly rolled it out to other teams. Our team started seeing the value of GraphQL, especially the light payload that gets delivered to clients. And now we have over 50 teams using GraphQL and deploying code to production. We have invested lots of resources over the last 3 years in dev tooling and building starter apps for teams to onboard onto GraphQL quickly, along with other tools and resources and Knowledge Hub. I'm also on Twitter at ShrutiKapoor08. And besides GraphQL and JavaScript, my other passion is also dev jokes. So I will be giving my first dev joke today. I'm going to ask you a question, and you can answer in the chat. I will be watching the comments. So here's the first question. Where did the API go to eat? I'll give you 5 seconds to answer in the comments. Where did the API go to eat? Does anyone have any guesses?
McDonald's? Fries before guys, fries before APIs.
Oh, I like that. I like that. I like that. Well, that's pretty close. The API went to eat to the restaurant.
That was good.
I have my
Okay.
handy dandy audience here in the times of 2020. With that, I want to introduce our first keynote panel, and I want to bring on our guests, Eve Porcello, Carlos Rufo, and Sean Grove.
Hello.
Hello.
Hey, guys.
Well, we're super excited for this panel. Mark and myself will be leading this panel. And Shruti, we're so excited to actually have you on the panel as well, just because you do so much in the GraphQL community. Does everybody want to go ahead and just quickly introduce themselves? Maybe a quick 10-second intro.
Sure. My name is Eve Porcello. I'm a software engineer and instructor at Moon Highway here in Tahoe City, California.
Hi, I'm Carlos Rufo. I'm a software engineer at Gracia MS, and I'm calling from Tenerife, Canary Islands, Spain.
Hey, I'm Sean Grove. I'm with OneGraph, and I typically work on a lot of GraphQL tooling, open source and closed source.
And we already know Shruti, and we already have introduced Mark. I don't think I actually introduced myself. My name is Tracy. You can follow me on Twitter at LadyLeet, and I am one of the co-founders of ThisDot. So amazing. I have been really impressed with how GraphQL has just kind of taken over everything. I love it, especially because it's, framework agnostic. So it's like, it doesn't matter what technology, what front-end JavaScript framework you're using. You're probably also looking into and or using GraphQL. And, one of the reasons Mark and I got together to put this event together is definitely because there's not enough really interesting enterprise conversations about GraphQL. But, you guys kind of being in the forefront of enterprise adoption in GraphQL, just kind of love to hear some of your ideas on, what are some of the most interesting things you've seen in enterprise adoption in the past year or so? Anyone?
You want to nominate someone maybe to lead off?
Well, I don't want to call on anybody because, honestly, it's like, you don't have to answer if you don't want to. So feel free to just jump in anytime if you guys want to. And also feel free to not answer if you guys don't have anything interesting to say.
I think that like GraphQL adoption in enterprise has been, it's still like relatively small, right? So like we live in a kind of small microcosm because we're eating GraphQL for breakfast every day kind of thing, right? But in the wider world, GraphQL adoption is still this very, very small thing in absolute terms. I think the exciting part is actually the curve, though, right? The rate of adoption is going up really, really fast. So whenever I go to like some of these more enterprise API conferences, you often hear that GraphQL is still kind of this new and scary thing. And so I think it's kind of important to keep that in mind because a lot of us will probably be on the other side of that curve, right? Really excited, really deeply into the tooling, about the possibilities and whatnot. But if you're kind of thinking about how it's coming into the enterprise right now, the strategy is going to be very different. If you realize that this is actually kind of a threatening technology in many ways, right? It kind of requires a lot of different ways of thinking about things, a lot of learning, that kind of thing. So I would just say like what we've seen has been, we typically don't even push GraphQL itself very hard. We kind of talk about maybe the architecture or the benefits, much more so than about the specific technology for the time being.
I think Eve, you had something to say as well.
Yeah, totally. I think you're absolutely right, Sean. All of us are GraphQL enthusiasts. We think it's super normal to use GraphQL for everything. But part of, as you said, the process of moving these technologies into the enterprise is learning and making sure people are comfortable with it and getting everybody on board. So I feel like GraphQL gives everybody throughout your organization who works with data at all, a really nice way of making sense of the data. So thinking about what a schema gives you, the organization of a schema, it lets you know exactly what fields are available, exactly what are the data types that are part of our domains. So I feel like getting everybody on board in order to make that push for the enterprise is super important, just because if people are scared, they're going to think it's a bad thing to get involved in the technology. And we want to make people not feel scared of GraphQL, because GraphQL will make their lives happier. So
maybe we need some
GraphQL
sort
is
of like fuzzy plush mascot that we can print out, so it's very, very safe and very warm.
totally just the logo, like a plush version of the logo with a
I
smiley
would have
face.
that.
Awesome. Yeah, so let's move on to the next question. So I was wondering, what advice do you all have for people wanting to bring GraphQL to their companies? Sometimes the first thing is to convince your boss, but maybe there's other ways to go about it. What are maybe some tips or best practices you've seen?
Yeah, I think I'm gonna jump into this. I think like just try it. I think I don't know, like when I tried the first time, like GraphQL, it was okay. This is like easy and it's like great, and it gives you a lot of like power tooling, as for example, like I don't know, like auto-generate docs and like overfetch, underfetching. So there are like a lot of like ton of resources from books. For example, there is the Learning GraphQL books by Ed Porcel that is here, which is awesome. And I think like there are like a lot of tooling tutorials, courses where you can just like play around with GraphQL, and then you are gonna be just like set up to like run the GraphQL API, whether it's you're gonna create a GraphQL API in the server side or you are gonna just consume it. So I'll say just go and try it.
Yeah, for us, what's been working really well is, what's been working really well is we kind of present GraphQL as one of the options of building REST API or building an API instead of like the option. So with that, what helps us is kind of compare REST and GraphQL and ask the team that's building itself is like, what are you looking for? Is this a good candidate for GraphQL? So instead of like forcing GraphQL, we kind of present it as one of the options, and that's been helping us in kind of showcasing the benefits of GraphQL upfront.
I also think that some advice I might give at the enterprise level is, if you're the champion for GraphQL, then go slowly and go deep. So one of the important things that we've seen is that you are going to mess up your schema design when you first design it. And so if you go very, very broad, you're kind of creating this huge damage area that's, it's going to send the wrong message to people who are trying to adopt your API. One of the examples here is kind of the best practices for pagination, so the connection spec. Almost everyone who starts with GraphQL looks at that and thinks that's madness. Like, that's so much work. Why would you want that? And then somewhere 6 to 8 months down the road, they think, oh, that's great. We should have that everywhere. The problem is, if you have kind of spread it everywhere, you've taken this shallow understanding and then spread it over all of your APIs and all of your data sources, then that's going to be very, very hard to recover from. Whereas if you pick one specific use case and you figure out what are the data sources here and go really, really deep and use that as kind of like your experimental, we're going to learn, we're going to make mistakes here, be prepared to refactor this in the future. That may feel less satisfying upfront, but 6 to 8 months down the road, when you start applying those same lessons across the rest of your org, you're going to have users that are much, much happier, and you're going to feel much more proud of the schema and of the kind of velocity that you're able to achieve across your team because of that.
Yeah, maybe a follow-up question for you all. I was wondering what use cases make sense for GraphQL and maybe some that don't. How do you choose that first experiment and first use case to try out GraphQL?
I think it's all over the CMS world, isn't it? I think we have some CMS expert here who might have a recommendation.
Yeah, I think it's a really good question. And I mean, like, there are like different use cases, right? But let's say that you want to kind of like query different like endpoints, so you want to support like different devices on the client side. So that's kind of one of the main points for like GraphQL to come in, or like try to, like nest data and just like send one smart query, process all the data in your device, and then get everything back. That, of course, it has their pros and cons, but yeah. But for me, kind of like, and I think it's related to another, like maybe another like discussion later, is like how the type system of GraphQL, it helps you to, I don't know, like first, like to have an like type API, but also like to communicate with your team. But also I would like to hear like Eve Porcelo thoughts, because she's been talking a lot about use cases of GraphQL. So I'm pretty sure that she can, share a lot of knowledge here.
That's a nice setup. I think that basically we moved to this area where we have all these different microservices and all these different data sources, and GraphQL gives you a really nice way of organizing those. So I think a lot of the teams we work with who find that GraphQL is useful to them is just bringing that huge web of data into one place, into one server. And I think that GraphQL really does work with any sort of data source. It's not tied to one database, which is kind of a popular misconception about GraphQL, is that there's one database and there's that you can only use it with REST, or you can't use it with REST at all. Instead, we can think about it as being this really good project manager of all of these different data sources and wrangling them all together.
Awesome, thank you.
We are getting some great questions in chat, but we won't move to those yet, but I totally want to move to those soon. So thank you, audience, for interacting, and we love seeing your questions, because that's exactly why we're putting on this event. One of the questions I want to ask is, do you all have any sort of interesting war stories or postmortems that you can share? Because that is interesting, right? You convince somebody, and then what? And then what was the actual result? Shruti, I feel like you have some stories you need to filter out.
So when I joined this new product that I was working on, we were really excited to start using GraphQL. This was like a long time ago, so we didn't quite understand like what GraphQL, what are the benefits of GraphQL, what is the best use case of GraphQL. So we ended up building like this orchestration GraphQL layer, really, which is kind of like a one-to-one mapping of a REST API. So we did understand how to build a GraphQL server and a client side, but the benefits of GraphQL, which is like you get only what you need, we weren't really getting, because it's a one-to-one mapping. So that was our learning story of, if you have a one-to-one mapping, GraphQL is probably not the right choice.
Yeah, I could share a story from PayPal too. So yeah, as you know, like a query can be super complex, and you could be requesting data from a ton of different sources. Early on, we actually, the fan out of maybe one of these queries would hit hundreds of services, maybe to resolve one query. And so yeah, we spent a lot of time early on, like memoizing and deduping those calls, and really trying to prevent too much pressure on our systems. We definitely got some complaints from some back-end API teams, like, hey, you're really causing us a lot of trouble here. So yeah, GraphQL definitely could have that problem if you're not careful.
I think a lot of the war stories or postmortems I've seen is figuring out how to use the schema and how to collaborate on the schema. So there's this one source of truth, right? With this one document that describes all of our API's types. But if you have many, many engineers across teams, across locations, managing that one document can be really tricky. So there have been a lot of fights I've seen at companies about who's going to be in charge of this, what are their responsibilities, how can we make sure that this document becomes something that can scale. And there's been a lot of pain associated with that at a lot of places, I think.
Awesome. So we're going to move on to, go ahead.
I was going to say, just as a quick overview, the kind of common theme with the stories we've seen is we've helped kind of companies introduce GraphQL APIs for their customers or internal, is that there's this like famous hype cycle graph for new technologies. And you kind of need to prep them for this because your internal implementation is probably going to follow something similar. Whenever you bring this in, you'll get people excited. They're going to be like, everything is possible. All the problems are going to be solved. And then there's going to be this valley where you actually hit the implementation phase. And all of those details that you're kind of glossing over turn out to be kind of painful to figure out. And a lot of them, like a lot of the velocity will run out right there. And so you kind of need to prep everyone that, hey, this is normal. This is going to be part of the process. And then there'll be this slow increase over the next couple of months as you actually start to reach and solve those problems, understand your details, and kind of implement it. So there's just kind of like a common theme that we've seen from our, so it's not a specific postmortem, but just like something we see a lot where you kind of have to prep that, you know, set expectations, timelines, that kind of thing appropriately before you're going to see the ROI kind of coming from the implementation.
Awesome. So I'm going to pick a question here. I think we have a couple people on the panel who could definitely answer this. So from Moo B, they're asking, GraphQL requires you to think in terms of graphs and graph queries. So how do you reconcile that with data sources that aren't in a native graph database, especially given the evolution of data models? Does anybody have an answer?
Well, I think it's not, I mean, it's unclear what the reconciliation of this means. But we deal with lots of models or APIs that are ostensibly not graphs. But almost every API is like semantically a graph, right? So if you think about REST or hypermedia, there's always kind of maybe you fetch a user and maybe it has a field that comes back that says the user friend's URL is here. So go and hit this URL if you want the user's friends. And that's a graph, right? So you're navigating a graph there. So I wouldn't think of it as so much of a graph as like a tree typically, where you have these models have connections to other models. And so that's why it's kind of important whenever you are implementing one of these GraphQL APIs that you kind of think about, well, what's the, not so much GraphQL, but rather what are the data models that I have in here, right? So, you know, whether it's users and posts or, you know, orders or whatever it might be, and how are they connected to each other? And if you start with that kind of schema design first and then figure out the mechanisms to actually map that onto your database, then you'll have like a lot of the problems that you kind of think ahead of time kind of go away. You realize that actually there is kind of this checklist of like, all right, to implement users, I have to implement these 3 fields from the database, and this one connects to orders, and so that's this kind of query into the database or into the API. And so once you have mapped out your data models, it becomes fairly straightforward, I think.
Yeah, I also think there's a little bit of misconception in the community about the database itself, like it needs to be in a graph database. It doesn't need to be in a graph database. You can actually just build it on top of the REST APIs that you have currently. Just to add to Sean's point, one thing that helps is like if you have 2 or more data types, for example, you have a library, then you have books and users and readers and authors. So what helps in thinking is, oh, if I have a library, I need to implement books, and then book would have an author and a title. So if I have an author, that means I need to write user. So that's how you kind of graph the relationships between the fields. So that's where the graph of GraphQL kind of comes from.
Yeah, I wanna build that up because I think it's like when you are creating the GraphQL API that you gotta create the single GraphQL schema is when you cannot like realize the different connections that you have like from your different data sources. Let's say that you're gonna have, I don't know, like those 2 SQL databases, 1 NoSQL, 1 graph database, 2 REST APIs, and other like third-party libraries and data sources. So then it's when you realize, okay, now here I gotta make all the connections, and GraphQL is gonna help you that. And also, I feel like for like doing that, all the teams, they are gonna kind of understand better the product and also the implementation that you got in the different data sources.
I think in the chat there was a follow-up question about we didn't cover maybe the second half of the question about what use cases are not appropriate for GraphQL. I'd be curious. We've been seeing more and more use cases where it actually does fit very well, but that's maybe because we have a hammer and everything looks like a nail. We have GraphQL and we're like, oh, this will definitely work here. So I'm kind of curious, maybe from your experiences, where GraphQL had a really hard time fitting in.
Yeah, at PayPal, sorry, I'll kind of flip it for a second. At PayPal, we've noticed that it really makes sense at kind of the edges of the stack, where product developers are iterating on it. Really makes sense. Like, I guess we really think of GraphQL as more of an orchestration layer or a facade that's really nice for UI developers to kind of fetch data and interact with data. We've tried it in a couple core services, like right next to the database, but just haven't seen as much, value out of it that we've seen at the edge. So, not to say it shouldn't be used in backend core services. It's just we haven't had good luck with it yet. But definitely curious about what you all are thinking.
Yeah, Shruti mentioned before about the one-to-one map of a database, and I feel like that's where sometimes you can get into some problems with GraphQL. Is potentially. We were talking with a guy who had a 1,000,000-line schema that was auto-generated from his data source. And he's like, yeah, I just don't know if GraphQL is right for this project. That document is pretty big. That seems very stressful, trying to manage that type of data table that has that much. And it was a lot of computation was going on with this data, and it was just really intense. So yeah, for me, I feel like if you do have these clear data types that you want to model, it is an automatic win. But as you start to try to make it fit your legacy data solutions, 100% of the time it doesn't always work, but oftentimes it does. So I'm not going to say that GraphQL is bad. That's not why I'm here today. So we could probably figure out a use for it.
I'd actually say there's like a use case that we've been surprised to find that is good. So it's not quite answering this question, but traditionally server-to-server communication has not been a strong point of GraphQL. So if you have like two backend services talking to each other, it's rare to use GraphQL in that case. We found that actually using GraphQL subscriptions over webhooks has been a really big win here. Because what this allows you to do is, even as a backend developer, you can go to the service, use something like GraphQL to actually expand and see a list of all of the events, select all the fields, all the data that you want from that event, and then say, whenever this event happens, reify, like figure out all this data and then send it to me. And so you can push down a lot of the complexity of discovering what events are available, of tying together all the data that's related to that event, and then getting it reliably sent to you. So it's kind of like where async API was one of those bastions that GraphQL kind of didn't touch. We've actually seen more and more adoption on the back end of that specifically. A lot of backend developers wanting to have webhook-based GraphQL subscriptions.
Great. I think we have time for one more question. I'm going to scroll up in the comments a bit. So Austin Reynolds had a question. Do you all use one massive schema file, or his question next was, or do you break it up into, reusable components? Yeah, I'm wondering, what have you all seen at either your companies or heard about at different companies? How do you share and collaborate on a schema at a large company?
We've seen a lot of folks breaking down their schema into either different types or different teams. So lately, with the rise of Apollo Federation in the last year and a half or so, that has been kind of the tipping point for a lot of companies that have been hesitant about GraphQL. They've seen Apollo Federation and they've said, this might be cool actually, because the product team can work on this, and then all of the users and authentication details can be in a different schema. And then we can take all of those. What Apollo Federation lets you do is have different schemas for different parts of your API. Then you orchestrate that all together into a gateway, so that earlier I was talking about schema conflicts and things like that. Those kind of get resolved if you have different parts of the schema in different places.
Well, that was a quick panel, and I wish we had time for more. There are so many amazing questions that I want to answer and that I know our keynote panel wants to answer too. So, keep asking those questions throughout the day, and, log on and answer some of these questions just via chat. So look out for that. Apologies that we weren't able to get to anything, especially Brendan. I think you had some good questions as well. So thank you so much all for joining us for this amazing panel, and just letting you all know that in about 15 minutes, we're going to start with our first talk. It's going to be awesome. Rahul is going to be talking. He is with PayPal, and he's going to be talking about a retro on the first public GraphQL API. Rahul is a lead product manager at PayPal and Braintree. So again, stay tuned, and we'll see you in just about 15 minutes. Thanks everyone for joining.
Hey, Rahul, how's it going? Oops. Sounds good. Let me just put this on here. Looks good. All right, everyone, we will be back in 4 minutes. We'll see you then. Hello, everyone, and welcome back to GraphQL Enterprise Connect 2020. I'm Sarah Renaud, Marketing Manager at This.Labs, and I'm so happy to welcome back Shruti Kapoor, our MC. Shruti, take it away.
Hey everyone, welcome back. That was a great keynote panel. Some really great questions from the audience as well. Please keep them coming. You guys gave us great questions, so now I have a great question for you. Now the question is, what did Constant say when he broke up with Variable? Put your answers in the chat. What did Constant say when they broke up with Variable?
Welcome back to GraphQL Enterprise Connect 2020. I'm Sarah Renaud, Marketing Manager at This.Labs.
Constant said, "You have changed." Ha 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 ha. I'm my own audience. Anyways, I would like to welcome our first speaker, Rahul Dighe from PayPal. Rahul leads the APIs and SDKs that power PayPal and Braintree's developer platforms. He's passionate about building simple and consistent developer-focused products that developers love and embrace. In his talk today, he aims to share a retrospective of learnings that he and his team has learned from launching a public GraphQL API. Rahul, over to you.
All right. Thanks, Shruti. Good morning, everyone. Good afternoon, wherever you are. As Shruti talked, I lead the developer platform at PayPal and Braintree. And my talk today really is focused on how we can build great APIs. My experience over the last few years has taught me that great APIs don't get built by accident. It takes a lot of time, effort, persistence. And this talk really is conversations that I've had, introspection that I've done, most recently with the GraphQL team, and bringing those learnings to you. Think of it almost as a retrospective that you would rather not have with your team 2 years from now. So the goal here is to give you some sense of how we do things at Braintree and at PayPal, and then hopefully you could use those learnings to avoid some of the things that we might have tripped on or things that we thought of, and make sure that we don't trip off later on. So having said that, let me quickly start by taking you down a bit of a memory lane to give you a sense of what the context or the business context is. So Braintree, for those of you who don't know, is a company that at its core processes payments. And the way we have done it by enabling a developer experience through our server SDKs. So think of it like a Java, PHP, Ruby SDK that a merchant can bring in and integrate with. We also provide mobile SDKs, and that's really been the foundational core of Braintree up from 2007, and since Braintree was acquired by eBay and then split into PayPal. So we have had a legacy of building SDK-focused products, and so come 2018, for commercial reasons, we thought that there's a segment of market that also needs APIs, and that's when we decided to embark on the GraphQL journey. There's a lot that's been talked about why we chose GraphQL, and I have links in the talk that you can follow through. So I'm going to focus more on the principles, but hopefully this serves as a context to where we've been coming from. And the key message here is GraphQL is new to us, and historically as a company, we've been tuned to building native SDKs or server SDKs. That's sort of been our bread and butter. Now, when we think different, the first company that probably comes to a lot of people's mind is Apple. And Apple, through its journey, has leapfrogged technologies, much to the dismay of a lot of its customers. Right, starting from just taking off CD-ROMs from your laptop, or taking off the headphone jack from your phones. It's just taken the approach of just taking the leap and going for the next new thing, and hoping that the industry would follow. And frankly, to their credit, they made it a great business to provide all these compatibilities between different product lines by great dongles. So we feel, when we were in 2018 and even now, we feel like in some sense we have taken that leap. We are doing things differently, and we sort of embrace that, right? And some of the things that we are different about is we use GraphQL. Payment processing is predominantly a server-side activity. It's not that there are client-side calls, but predominantly it's a server-side processing. So we use or we expose GraphQL, and a bulk of it is write-heavy, a bulk of it is server-side. Braintree has adopted GraphQL, and if you look at the PayPal wider ecosystem, it's very much still REST. So we are one amongst a kind even within our own company. We are definitely one amongst a kind even within the industry where GraphQL is not pervasive at all. And even our technology stack is built on Java. So the point I'm trying to articulate is we realize these things going in. It has implications that each and every one of you should consider I think in some quarters, using GraphQL for client is a little bit of a no-brainer in some companies, but for us, it has a unique set of challenges and unique set of constraints that we were working with. And so it's important to sort of keep that in mind and when you listen to the talk, because this sort of gives you a context of what our starting point was. Now, in terms of API thinking, and this is universally true, doesn't really have to be GraphQL. The last few years in the industry has been all about how we should think about API first, how you should think of APIs as products, how you should have a governance model, have KPIs for APIs. So I'm not going to spend any time talking about these. I'm presuming that these best practices are something that your organization has embraced, or these are best practices that you've looked at and you've decided that it's for your own organization or cultural reasons, not the best thing for you. But I just wanted to put it out there to give a sense of, at Braintree and at PayPal, we consider some of these values to be core when we build our APIs. And when you feel like you're putting all this effort, but something doesn't seem to be going right, I think it would be useful to reflect back on whether these core basic principles, which most in the industry consider gospel at this point, is something that you are not incorporating or not really internalized. Now, the first thing, as you can imagine from the context, we were a very much an SDK-focused company or a REST-focused company. And so to us, it was super important to think about how do we embed this notion of GraphQL first. When you embark on a GraphQL project or a program, you'll soon realize that you would have folks coming in asking everything from what's GraphQL to, why are we not using REST? Or, if they've gone sort of beyond it, they would say, well, in our case, it would be, we'll just build it on SDK and we'll come to GraphQL later. So there are a whole myriad of reasons why, especially if you're moving from one stack to another or one technology stack to another, you would have to make sure that your company makes effort and your GraphQL team makes an effort to embed that GraphQL first mentality within the company. For us, it's been a combination of top-down communication. A lot of it has to be also organic. GraphQL as a technology has many enthusiastic followers. We've had folks who have joined the GraphQL team and then moved on to other teams, and they've taken that knowledge and wisdom with them. So it's important. I won't be able to answer what's right for every company and every organization, but it's absolutely important that when you take on a new technology, and if that's what you think is going to be the default for your organization going forward, that you take the time and effort to embed that GraphQL first mentality. Now, in terms of market adoption, it's all well and good if you launch a product, but what if nobody ends up using it? And for us, this wasn't an internal API that was powering our mobile apps. This was really a replacement for what we have today on our server SDKs. So when I think about market adoption, and market adoption starts, if you're a large company like PayPal, or even if you're a small size company, you would have business development, you would have sales, who are like the first tier of folks that you need to work with, and then they are the ones who take your message to your customers. So it's very important that you look at how you are going to get a market adoption. And for us, it really boils down to 4 things, which is interoperability, trust, knowledge, and parity. To put it simply, interoperability just means that if you are out to the market with something out already and you launch something new, how interoperable it is, because API callers are not going to switch from one stack to another just because you ask them to. It's going to be a phased approach, and so it's really important that even disparate stacks work with each other. Trust is super important with any new thing. There is sort of a need to build an inbuilt trust into, is this just something that the company is trying out? Is there really investments going into it? So it's really important to build that sort of trust. And find ways to communicate the trust first to your sales and business development folks, and then eventually to your customers. If you look on Stack Overflow and look for PayPal and ask a question, most likely you're going to get an answer. When you launch a new technology like GraphQL, it's going to take months, if not years, to build that sort of a repository. And so it's important that there are ways in which people can look, find information. And while that's sort of getting built, at Braintree, the GraphQL team does a great job at being almost sort of front-line support, because not only are we trying to build an API, but we are trying to make sure it gets adoption. So it's really important that people spend the time and make sure that it's just not about building the APIs. It's about spreading the knowledge. It's about building the trust that's core to your whole program of getting GraphQL API out. And the last thing I don't talk about is parity. Before I joined PayPal, I used to work at American Express. And at American Express, as a loyal employee, I used to only carry the American Express card with me. And I still remember a time when I tried to buy a cookie for my daughter, and they just wouldn't accept Amex. So, knowing everything that I knew about Amex and how prevalent it is, I realized that there just isn't parity. I just have to have a Visa or MasterCard in my wallet or have cash. And the whole notion of parity really becomes important, because that one moment really left a sour taste in my mouth, even though I was an employee of Amex at that time. So when you're asking people to adopt a new technology stack like GraphQL, and particularly when in the case of Braintree, where we have an SDK that's mature, you really don't want to be in a position where someone starts adopting it only to realize that some of the core functionality has just been missed out. So as you embark on this, think about how you can offer parity. Think about whether offering parity is important to you. And if offering parity is not important, be upfront about communicating that you're not going to get X and Y on this. So that way people are not disappointed when they try to go and use your GraphQL API. We've always approached GraphQL as a fresh perspective. We have a strong legacy of SDKs and mobile apps and that we have brought to market, but we use them as a way to really learn and use it as an opportunity to improve. The exercise wasn't really to take what you have in SDK, move it over to GraphQL, or take what you have in REST and move it over to GraphQL. It's really looking at where is it that we can actually use GraphQL as a technology to its fullest. And one of our guiding principles really was, nothing is sacred for us. We are happy to take up the challenge, have the debate with teams that have been put this in a particular way in our SDK. And really, it to us was always about looking ahead and looking at what makes sense, particularly when we are using GraphQL, and not so much about having parity for the sake of parity. So I would strongly encourage that when you're looking at GraphQL and you're building this up, you really take that fresh approach and think about what at best the technology offers to you or the API style offers to you. And that's probably going to be sort of a winning equation, much more than translating A to B or REST to GraphQL and that sort of thing. One of the things that we use extensively is this notion of batching and orchestration, and more specifically, the idea that you could run one mutation, take the output from it, share it with the next one, and allow it to transact. One of our guiding principles always was to build fine-grained mutations, and the idea was that we realized one of the things which our SDK did absolutely well, which our customers love a lot, which is, it did multiple actions which together sort of made sense, or which required otherwise to make multiple calls for the wire and bring it into two. And that led for a very efficient system, but we felt that with GraphQL, we really had the opportunity to build mutations that are very fine-grained, that work with each other very well. But what we could do is provide a way for our API callers to integrate it in a way that makes sense how they want it. We have a notion of how things should be grouped. but we feel like that sort of limits the creativity. Instead, we chose to make it as fine-grained as logically possible. It's not that we don't group things when it makes sense, but our philosophy going in was to keep things separate and then provide a batching and orchestration layer to really bring it together. We talk about naming a lot. I don't know about you guys, but for me, it's not finding my name on the Coke bottle has been very upsetting, right? Particularly when Coke launched it, and it wasn't coming from India. I didn't really expect to find my name on the Coke bottle, but it was a little bit so. And to make matters really worse, when Coke really launched this idea that you could go online and type your name and get a Coke bottle, guess what? I couldn't do that either. So the point that I'm trying to make is, as a company, we think about naming quite a bit, and I'm sure there are parents in the audience and people who have had participants in naming their kids. I had twins a couple of years ago, and this is how we approached it. As a good product manager, I thought about, hey, who's my audience? And having born in India and now an American citizen, I'm like, okay, now our core audience is typically going to be people from India or Americans. And so when we were naming our kids, we're like, okay, that's the audience. And we're looking at, okay, does the first name and last name rhyme? What's the probability of them getting teased when they are in school or when they go to high school? Is it similar to someone else's name in the family? Is it trending? Is it common? Is it obvious that it's a boy or a girl? Are there any alternate pronunciations? So we spend a lot of time, and I'm sure the parents out there spend a lot of time, months, a lot of fights over it. And we feel like, that's the sort of rigor, that's the sort of time that one needs to spend when you're naming APIs. And I know it's tempting in GraphQL to just deprecate things and just rename it, but there's a cost involved in doing all of it. And so our encouragement has been to really obsess about naming. And some of the things that we found repeatedly that people do was use things that are in the database schema, even within the same mutations, even if it's like an ID, they call it identifier at one place. They use things which are a mix of British and US English. And if you're a large global organization and you have multiple teams building your APIs, these language nuances and the words that you use eventually creep in. We've had scenarios where we are using words that are just redundantly long, things which are unnecessarily abridged. We are not living in the world of mainframes anymore. We could write account instead of ACCT. These are just some of the things we need to think about. And in the payments domain, we've always had this challenge of, do you make our APIs such that even developers who really never understood payments or never really worked with payments, how approachable it is to them? And so it's really taking all these things into account. And the answers might be different for your organization, but it's absolutely important that your name should be, it's something that you really think about as a first-class citizen and really obsess over it, have the debate that you need to, because it does play an important part in just making sure that your overall APIs is great, it's coherent, and it's simple and consistent to use. Now, you could do a lot of these things, but at the end of the day, building your GraphQL API is really, to me, is a start, right? That's an absolute bare minimum that one has to do. But in the case of PayPal, and I'm pretty sure in the case of your organization as well, there is an entire ecosystem. So particularly at Braintree and PayPal, we have developer docs, sandbox, we have a community forums, we have post-launch monitoring, optimizing. It's really all of these pieces that I feel should come together to really make for an amazing experience. You could just build the best amazing GraphQL API, and I'm completely sold that there's great tooling out there. There's so many things that come out of the box and that take you halfway through, but you really need all these pieces to come together so that you can actually package a product and get it to market in a meaningful way that makes it an attractive value proposition, just beyond the fact that it's GraphQL and it has all these properties that you would like. So I would really encourage you to look around you, look at what makes sense almost from a end user perspective. What are all the different touch points? And you'll realize that, from the point of them actually onboarding to using your GraphQL to make the first call, there's a series of things that you need to do. And it's important that you focus on it, take the time to do on it, and that's really going to make for a winning product. Now, having said that, I've done it many times, and this takes a long time. It's not going to be something that's going to be quick and fast. So be ready to invest the time in it, especially when you're trying to switch stacks. You're adopting GraphQL and moving on from an old stack to a new stack. You might have the first GraphQL mutation ready in a couple of weeks, but it's going to be a long haul before you can actually get something and do a meaningful transition all over to GraphQL. For us, it is and it will continue to be a multi-year journey. We are particularly committed to it, and I hope you the best of luck. And wherever you are, given the times we're in, stay safe. And if there are any questions, I'm happy to take some questions now. I'm going to be around in the chat later around as well. And if not, you could just shoot me an email. I love talking about APIs, and you can always reach back to my team and get some more questions answered if that's what it is. Thank you so much.
Rahul, thank you so much for that talk. We actually do have a couple of questions, so I will get started with this first one. Which protocol for GQL subscriptions for SPAs? So what kind do you use? I've heard WebSockets are hard to scale at certain size. Interested to hear how you do it.
Yeah, so I think it's a bit more technical for me to answer at this point. I'll have someone in my team, but we don't offer subscriptions yet. It's something that we are looking to offer very, very soon. It's on my roadmap to attend or get to, but I'll follow up with questions and see how best we're doing it. We have some plans. We just haven't gone out yet with it.
Great. Another question we have is, what is the charter of the GraphQL team within your organization?
Yeah, so the charter of the GraphQL team, it started out really within Braintree, which is a PayPal service. And we were super focused on trying to make sure that GraphQL as an API is successful, and we can improve the model. Lately, we are expanding the charter as we bring on other business units within PayPal to bring and adopt it. And it's a long road ahead for us. But where we see ourselves play a role is to make sure that some of these principles that we have honed in over time is a philosophy that we carry on. And so our charter really is at this point to educate the wider PayPal ecosystem about how do you build great GraphQL APIs and really help them in that process so that they don't trip over or they don't go through that long experience that we had just learning doing it for the last 2-3 years.
Absolutely. I have another question coming in here. Do you use GraphQL for file uploads, and how well does that work?
Yes. So again, interesting topic. We've file upload is a challenge for us. We've sort of deferred those use cases because we have other things we thought we would get to parity first. But we would have a good answer for you because we are going to be implementing file uploads in the next quarter or so.
Oh,
so
wow.
If there are any questions, you have my email, please reach out to me, but you are going to see an implementation of it very soon. So far, we haven't had a huge need for it. There are scenarios in payments where, let's say you do a dispute and you want to prove yourself that you actually didn't get something and you had to upload it. That's a fragment of our overall use case, and we've sort of deferred it, but we understand it's complicated. Mm-hmm. That's why we haven't done it yet, right? Even if it was a matter of doing it a week, we would have done it by now. And we share your pain. You're not alone here, but we are happy to share the learnings, and we might put a blog post up on file upload once we finish doing it.
It's great to know. Breaking news. We have one more question. How do you handle your authorization?
Yeah, so for most parts, PayPal as a infrastructure a lot of it is really solved for us. So we don't have really have to worry about every single bit of the puzzle. So it was not something that we did ground up, but I'm happy to go on the chat and maybe ask a follow-on question and see if there's anything more specific that we can answer.
Wonderful. If anyone else has more questions, just feel free to give us some comments here. We'll make sure that we'll get those answered. Rahul, thank you so much for your time. It was a wonderful talk. I do want to highlight that PayPal is hiring. So if you want to work with brilliant people like Rahul, feel free to apply today. And we will be back. So Shruti and I will be back with Sam Parsons and Kyle DeTella. We will be back in about 20 minutes. So thank you, Rahul, again. And we'll see you guys soon.
Mm-hmm.
Hey, Kyle, how are you?
Good. How are you, Sarah?
I'm doing well. Yep, you sound great. Do you want to share your screen?
Sam's actually going to be the one. Sam's going
to
to present, so we'll let him join and do that.
Great. So we will wait for him. Everyone, we will be back soon in about 9 minutes. So stay tuned. Hi, Sam. How are you?
I'm good. How are you doing?
I'm doing well. If you want to go ahead and share your screen, and we'll just do a quick check.
Okay. Share screen.
Hi, Sam. How are you?
I'm good. How are you doing?
I'm doing well. If you want to go ahead and share your screen, and we'll just do a quick check.
All right. Does that work?
Awesome. Great. All right. We are back in 8 minutes, everyone. Stay tuned. Hello, everyone, and welcome back. Our next talk is up, Building a GraphQL Platform. Shruti, I will have you take it away for intros.
Thank you, Sarah. Hey, guys, welcome back. I hope you had a good break. I'm really excited for this talk because GraphQL Platform gets talked about so often, especially now with the introduction of Apollo Federation. So I'm really looking forward to this talk. We have with us today Sam Parsons and Kyle DeTella from Braintree, and I'm really excited for Sam and Kyle to be here. Hey, guys.
Hello.
Hello.
So Braintree has been really helpful in adopting GraphQL, and I'm really excited about this topic. Sam and Kyle, take it away.
All right. Yeah. So good afternoon, good morning, everybody, wherever you are in the world. My name is Sam Parsons. I'm a software engineer at Braintree. And also speaking with me is Kyle DeTella. He's engineering manager. We both work together on the same team called Custom Actions. More of that to come. Also, I'm involved with the GraphQL over HTTP spec working group as part of GraphQL Foundation. So, Kyle.
All right. So as Sam mentioned, we work on a team called Custom Actions, which we'll dive into a little bit. But that's part of the Braintree platform at PayPal. And what we're doing is we're servicing the commerce needs of large enterprise merchants. And as it turns out, for large enterprise merchants, those ecosystems are quite sophisticated and rather complex. And I'm sure everybody can imagine all the different scenarios, or you've been involved with a lot of those scenarios. But the thing is, as a payment processor, we've come a long way from just cards and wallets. And not to trivialize those things, but we do them well. And there's so much more that happens in this space that we need to be able to handle and account for. And so we've been doing a lot of discovery. And over the past couple of years, we decided that we were going to tackle some of these challenges in a new and interesting way. So we thought to ourselves, what if we could make we could build something that would allow us. Next slide, please, Sam. What if we could do something that would allow us to extend Braintree more seamlessly? And if we could do that, we could enable our engineers to deliver new domains faster. And we could also enable merchants and partners to add to our ecosystem and make that ecosystem much richer. Next slide, please. And so that led to the Custom Actions product. And the first phase of the Custom Actions product was centered around letting people implement payment methods, Braintree engineers and PayPal engineers implement new payment methods on the Braintree platform really quickly. And what the Custom Actions platform is, it's actually a serverless platform where integrators provide code to us based on a specification. Everything is fronted by GraphQL. And you write handlers, Custom Actions handlers, so you can implement the auth, capture, void, refund behaviors of a payment method, whether that be talking to a downstream provider, whether that be doing some custom business logic. And then what that means is the merchants can use the same uniform interface to interact with those capabilities through our API. The problem is that that initial model is constrained to like auth capture credit card flows, and it doesn't really account well for more sophisticated or more interesting flows or new types of payment methods that come along, like order-based and credit-based payment methods, where we need richer data up front. And so we added a new layer that are called payment contexts, and that allows us to have merchants send us data that might need to be resolved ahead of actually authorizing a transaction or paying, such as cart data, checkout data, anything you might need. We've had merchants use it for strong customer authentication. But the problem is that to create such an abstraction where developers can write code and put it in our system, and then there's a uniform API for merchants to interact with, all we can really do is provide something like custom fields, which we did. So in our GraphQL API, we have a create custom actions payment context mutation that's backed by these individual resolvers for different merchants or different integrations. But the problem is that the data coming in is untyped. And so there's fragility in that layer between the merchant and our API, and also through our API and the backend integration. And on top of that, because it's just a list of maps that all values are strings, it's a rather clumsy data model, and there's a lot of room for error on both the front end for the merchants and on the back end for the integrators. So to give you kind of a higher level picture of custom actions, when you think about it, on the left here, we have a merchant interacting with Braintree through our GraphQL API. They can interact with cards, banks, wallets, all these other domains that we provide. But we added this new custom actions abstraction. And this custom actions abstraction allows us to stand up this service behind our GraphQL API that speaks GraphQL, but instead of it being built each time we want to add a new feature or new domain, we add a new custom action and allows us to share that same uniform interface on the front end. So this kind of represents that auth capture void refund model where you can see those little functions on the right. Each one would be one of those phases of a transaction. But we can do better, and we can go beyond payment methods. We want to do a bunch of payment methods, but we can go beyond that. We can model unique and interesting domains, and we can enable integrations that we might not even have thought of yet or haven't been able to even imagine. And to do that, we need to do something really interesting. And we thought to ourselves, what if anybody could customize the graph and make it customizable per merchant? What if we could resolve operations in a Braintree environment via custom code executed in our environment, authored outside of our environment? And what if we could build a new product domain without standing up a new service for every single thing we have to do? And what if we could do all of this without author access to the GraphQL API that Braintree serves to our merchants? And with that, I'll let Sam take it away.
Thank you, Kyle. So yeah, we're going to talk about kind of the next evolution of custom actions into the custom actions API. And so we had a couple of principles that we want to keep in mind, both as we're building the first version and continuing to build this newer version of custom actions API. And one of those is ensuring that we allow for lots of development to occur at the same time. So rather than getting bogged down through kind of bottleneck of us doing all the work, maybe there are some external developers, third-party integrators, merchants themselves, all who would like to contribute and be willing to do that if we could provide that capability. And so we want to increase and maintain high product velocity. Secondly, to support that is a way of, we call it platform thinking. So approaching this problem not just as like we have a set of 100 different individual use cases to solve. We would like to think about it on a level up from that. How can we create the abstractions we need in order to solve the class of problems as a whole? In order to support that, we also have adopted a serverless mindset. And so as far as that goes, functions are our core primitive throughout the architecture of custom actions. And that gives us a number of things. First of all, it gives us scalability. We can scale across regions, across the world in order to respond to demand. We also have the security of isolated code. So if we get code that comes from a merchant, that we know that it cannot do anything outside of its own sandboxed, isolated environment, which is crucial for us. PCI compliance, security is top of mind for us. And also, it's a freedom to use a variety of different runtimes. So for example, people may like to contribute their extensions in other cool languages like Rust or things like that. We can support that going forward by approaching with serverless. And finally, obviously, GraphQL. We're here for GraphQL. So that's a core part of our product. Rahul kind of talked about that. And so we're basing all of our work from that GraphQL service. So we had a couple of constraints that kind of forced us in the solution that we're building. So we'd like to maintain really strongly typed integrations with our API. Kyle talked about some of the downsides of where we got to within the first round of custom actions and some needs that we had, and we weren't able to fit them really well. So that's something that we would like to continue to maintain, is really strongly typed integrations in the API. We also don't want to have direct access to internal components. So this code kind of goes back to that isolated part of serverless. That is really important for us to have isolated code that's running here. And the extensions should not hinder the core product development. So for example, we have our core product on GraphQL for Braintree. And we want to be able to make decisions that are best for the business and don't want the extensions that we've added to hinder that as we go forward. So we need to add the extensions in such a way that it still gives us free reign to decide what the future of our core API looks like. And secondly, we can't disrupt the performance of that core API either. So we have millions of transactions coming through, and those are on the critical line for many businesses. Performance is of utmost importance, and so we can't disrupt that performance at all. We need to be able to add the extensions in such a way that they are only additive. Additionally, we would like to do this per merchant. So for example, merchant A wants a specific extension and merchant B wants a different one. They don't want to see each other's extensions. They should not even know about their extensions of the other merchants. So that's another constraint that we had going into this. So one of the kind of the things that we believe really is that we want to make it super easy for our customers to integrate with our services. And one graph, or the first principle from the principal graph, really encourages us in this direction. So your company should have one unified graph instead of multiple graphs created by each team. And we're embracing this because this is what supports, makes it easy for our merchants to easily access any services that we have. So that gives us a constraint in that we want to make it all accessible under the same graph and it look transparent to our merchants. Now, usually this is handled through federation. If you have multiple graphs, you use federation or something like that to stitch them all together. So a question for us, is federation a good fit for what we're trying to do? So we had a desire to not have a gateway. And the reason is that our core product really is a GraphQL gateway that then goes to a lot of different services, REST services, and gRPC services. And so we don't want to introduce an additional gateway in front of that. And federation would have required that we were to introduce a gateway in front of our core product, which we didn't want to do. Our core product is a gateway. Performance is ultimately really important. So we can't do that. Secondly, we want to do schemas per merchant. Like I was just saying, we want to have different schemas available if you're logged in as a different user. And with federation, the approach is assembling one general unified graph, whereas we kind of want n number of unified graphs. So this is also kind of a sticking point. And thirdly, coming from one of our principles is the core product schema. That is more important than the extensions in our mind. Whereas in federation, the mindset and the approach is that schemas all have equal importance. So if you kind of compare on the left-hand side here, we have federation. You have a number of different graphs that you are orchestrating together under a federated graph. What we want to do is kind of diagram on the right-hand side shows you, is we want to have a core schema. We want to have multiple extensions to that schema. But let's just call that graph A for merchant A. We also want to have a graph B that has a different set of extensions of the core schema for merchant B, and another graph C, and so on for all of our different merchants. So if you keep that in mind, that's kind of like a dimensional change. Like we want essentially something close to a federation, but for multiple graphs, for multiple users. And yeah, so that drives us to kind of a picture of our architecture and how we're approaching this. So I'll just kind of walk through each of these code paths. So merchant A comes in, goes to our GraphQL API, Java-based GraphQL API, and they get the core feature set. So they get transactions, disputes, tokenization, etc. Merchant B has deployed its or enabled this FUPE custom action. And so when they go to the same GraphQL API, same endpoint, they use the same authentication mechanism with their own private keys. And when they get there, they see the core feature set, but in addition, they see what's been made available by this FUPE custom action through the Custom Actions API. And when they call that FUPE, they would be interacting with functions that run in our serverless platform, essentially cloud-based. And so that means that the core Java service doesn't actually know how to resolve these fields or anything like that. Those are all delegated externally to serverless function. Merchant C, in a similar way, when they log in or access this GraphQL service, they see the core feature set plus a different set of custom actions. And therefore, these are different types and resolvers and mutations that are available in that GraphQL API. Again, hitting functions that are in our serverless platform. So at this point, I'd like to show you a little bit of a demo. So what we're going to do is we're going to take an existing, we're going to take a merchant and we say, let's build a custom action for that merchant. And we're going to integrate it into the graph. So before I actually show you doing that, let's just have a quick look at the graph here. And so we're going to refresh the schema, and we'll go back to merchant A. Sorry. Refresh the schema here. And let's just have a quick look at the schema. This is the Braintree API schema. You can see there's a bunch of query. You can see mutation. We have loads of mutations. We're a very mutation-heavy schema. So have a look here. Let's run a quick ping, and you see we get a response right back. So this is, so far, just interacting with the Java-based GraphQL API. And so we're going to extend that through a custom action API. Over here, we have a scaffolded custom action. It's got an empty SDL, and no handlers are built yet. So we're going to go ahead and we're going to build a schema for this custom action, and then we'll build the handlers as well. So first of all, we're going to have a demo ping, and that's going to return a string. And we have to also add this custom action directive. This ties it into a handler. We're going to have some dev tooling once we release this platform that will make this custom action directive added automatically for you. So just kind of a bit of heads up about that. So then also let's add another more kind of complex type, and we're going to ask for an input, and we'll return demo payload, and also I have to add that. So let's define our types. Demo input, and some value, string required, and let's add a type for demo payload, and let's add some key here, and okay. So now what we're going to do is do BT actions cogen. So we have a command line tool here, CLI tool, that we allows us to kind of like dev tools for people who are developing custom actions. So it's one of the tasks you can do, which is generate the handlers. So let's go across here. We can see that this generated some TypeScript types for us from the schema that we just built. And additionally, it scaffolded up 2 different handlers. So here's the demo ping one. So that's all set up. And if you look at demo complex, you'll see here it is taking in some input as well. Great. So let's go ahead and implement just something really simple here for demo ping. We're going to return hello, everyone. And now let's do something similar for the complex one. So this time we're going to use that input, and we will return an object. And if we want key, let's use that input. So args.input.val, I think it was, and we return a number. Today's the 14th, so we'll return 14. Save that. And then in our tooling, we have also an action for BT actions deploy. So what this is now going to do is it's going to take the schema that I just wrote. It's going to take our handlers. So the schema is going to go into a schema registry so we can access that from within our Java service. And the custom actions, each of those handlers that we just wrote here, are going to get deployed to our serverless platform, so that whenever those aspects of the graph are requested, it will resolve them using serverless functions that we just wrote here. OK, so we're all set there. So let's head back over to our demo here. I'm going to refresh the schema, merchant A. Let's have a look at the documentation here. Go back to here, click query, scroll down. You now see demo ping and demo complex are available in here. So now let's uncomment demo ping and click send. And we can see that what comes back is hello, everyone. Immediately comes back. Secondly, let's now go to a more complex request. So in here, let's use that demo complex that we created. And hit send here, and you can see it says hi there. And if I change this right here, you can see it responds to that and is hitting our handler there. So now just one more thing is, what happens if I log in with some different credentials with merchant B? What's going to happen here? So let's again fetch the schema and show the documentation. You can see that the values are not present, and demo ping now doesn't work. So if you go to demo ping, there's no notion of that. And the same also with the complex types here. Errors are coming for everything. That's because it's not available, and that's expected because merchant B hasn't deployed these. So going back to merchant A, again, everything's available. So looking forward, some of the things that we're planning to extend this with is utilizing types from the core schema. So in the demo that I just showed, we just created our own types within that schema in the custom actions. But what we didn't do is extend or utilize types from the core schema. So that's something that we'd like to add. Continue to enhance the dev tooling. For example, that custom actions directive that I used, we want to make that automatic. And allow our contributors to add the full suite of GraphQL things like custom directives, scalars, etc. Many of our integrators would also like to use data storage. They have some needs for different usages that they would like to use some sort of data storage from within these functions. So that's something that we'd like to build, as well as hooks for the operations. So any questions?
Yes, we do have a couple questions. So I will get that started. Our first question is, would gateway be a single point of failure?
Yes, you couldn't access the custom actions if the gateway is down. And by gateway, I mean the GraphQL core service, I'm assuming. So yes, that's true. But we also, from our perspective, that's already on the sort of the hot path of critical support for our organization. Like if that goes down, there's many, many problems, many bigger problems than just custom actions not being available. But regular credit card transactions can't be processed. So very, very important that that's up. So is true that it's a source of failure, point of failure, but it's kind of a known. It has to be up for our organization.
Derek Anderson has a question. How do your APIs federate error handling?
So the errors right now, from within the custom actions API, we are responding with errors as data. So we would respond those errors back to the core service, and from there it would be resolved and decided whether to surface that as a message to the user or to hide some of that.
Great. We actually have a lot of questions coming in. We'll try to get to all of you. Noel had a question. What happens if a merchant called another merchant's GraphQL API?
Oh, yeah. So I demoed that. They can't do that. So if when they log in and they are accessing the core product, then they'll get the core product for them, right? So when they create a transaction, it would be a transaction for them, not for anyone else. But if you attempt to access a custom action API that is for another merchant and hasn't been deployed for you, you'll just get non-existent. So from a GraphQL sense, it's 100% compliant. It's just not introspectable. It's not even there. It's not present. They would have no knowledge that it was there. And if they attempted to call it, they just get 404s, essentially not found.
Arvind Raj is next. How does a merchant developer view the logs on a deployed handler, especially in QA stage and prod?
That's a great question. So that's really some of the developer tooling that we would like to improve upon. Right now, it's a little bit manual, trying to look at the logs. So we'd like to make it such that the developers who are integrating with this can easily see the logs, both errors and success, for any custom actions that they've deployed. So that's something that we intend to provide more in a much nicer way than we have right now.
Great. Have another one coming in here. How do you ensure that additions to the schema by merchants don't break the core schema or create conflicts? Do you also provide any tooling for them to ensure backwards compatibility?
Okay, so there's two questions there. The first one is, how do we maintain non-collisions with the core schema? So I didn't show this quite in the demo, but what we're actually going to do is have naming conventions around everything that's added through custom actions, such that you can't overwrite or even attempt to overwrite or collide with something within the core schema. So everything would probably be prefixed with custom actions, and then you would be able to see and access that within your GraphQL schema when you're logged in. The second question, can you remind me? There was a question.
Do you also provide any tooling for them to ensure backwards compatibility?
So that's a really good point. I'm guessing that means, like, if I roll out 2 different versions of my custom action, I change something, would that break people? Right now, there isn't any safeguard in place for that, but that would be a really good feature, I think. So, you know, kind of more of that developer experience that we haven't yet built out, but would like to really make that seamless and help people not do bad things.
Question from Igor. Do you run a separate CI/CD pipeline for each merchant? And also, is there a merge queue to get integrated into the production schema?
No, see, that's the magic of this, is that we're not running a separate CI for each merchant. We're running the same service, the same core Java service is still in place. That architecture is unchanged, and that's just the core schema. And then for each merchant, this will be at request time. Once we roll this out, that they will get these additions to their schema. So that means that there isn't a CI process that has to run for the schema as a whole. What does have to happen is when we do that deploy, there's some steps that I guess is somewhat like a CI step, some post-deployment steps in order to get the schema together and register it so that the Java service can access it.
All right, about 3 more questions. We'll try to get to all of them. We have 3 minutes left. Can you access schema from all the GraphQL apps through the gateway?
Can you access schema from all Graph? Go ahead.
I'm not sure I completely understand this question, but I think it might be asking if Braintree exposes all of our GraphQL services through this API gateway or through this GraphQL gateway. If so, not necessarily. Everything's kind of scoped per feature that we roll out.
Ramyak, how did you create that layer of abstraction between different merchants?
So I think the question here is, how do we on request time give them a different extended schema depending on your merchant? So that's that is basically done by taking 2 schemas and then merging them together at request time, and then we'll be optimizing that so that if it's for the same subsequent requests coming for the same merchant, you'll get the graph that's already been generated for that merchant.
And really quick, one more. We have, can you have collisions between 2 different merchants' custom action names?
Yeah,
so I'll take this one, Sam. So technically 2 different merchants could create a custom action called foo, and it is scoped and isolated to their merchant account. So they would have custom action foo for merchant A and merchant B. Each would be corresponding to the one they created. One of the problems that we do have with this is if a merchant creates their own foo, let's say, and then later on Braintree or a partner adds foo to like an ecosystem or like a marketplace that they can use, there will be a conflict there. So that's something we'll kind of have to figure out. But as of now, everything's scoped per merchant. individually.
Great.
So that shouldn't be a problem.
Sam, Kyle, thank you so much for your time. Everyone, thank you so much for your questions, your comments. If you have any more, just continue to ask them. We will try to get them answered as fast as possible. We are up in 15 more minutes, so grab a snack, grab a beverage, and we'll be back soon. Thank you, everybody.
Thanks. Take care.
Hi, Joey. How are you?
Hey, pretty good. How are you?
I'm doing well. So I'm just going, you sound great. I'm going to make sure that's ready.
I'm
Yep.
sharing the wrong screen. Let me figure out how to.
Okay. I'll remove it for now.
I need to figure out which one is the presentation here. Okay. Does that look more like a?
Yeah, that looks great.
Okay.
All right, everyone. We will be back in about 7 minutes. Stay tuned. Hello and welcome everyone. We are excited to get started with our next talk. Happy to welcome back Shruti. How are you, Shruti?
I'm good. How are you?
I'm doing well. It's been a great day.
I know.
I will let you take it away from here.
All right. Hey, guys. Before I say welcome back, there was a request for music before welcoming back. Your wish is my command. Derek Anderson, this one's for you. What day is it today?
It's Friday, gotta get down on Friday. Everybody's looking forward to the weekend,
I'm accepting song requests. Anyways, welcome back, everybody. So today, next talk is going to be about GraphQL security by Nenni from PayPal. I'm super excited about this talk because this talk is about the security risks and concerns that are new or different in GraphQL. Joey leads all GraphQL efforts from the web platform team at PayPal. Drawing from his prior experience at White Hat Security, a web security firm, and almost 9 years at PayPal, Joey is ready to share his insight on security as it relates to GraphQL. Welcome, Joey.
Hey, thanks for the introduction, Shruti. Welcome, everyone, and thanks for coming to my talk about GraphQL and security. My name is Joey Nenni, and I'm a software engineer at PayPal. Let's jump right in. What is GraphQL? If you're here, then you probably already know what GraphQL is. If not, the website says, GraphQL is a query language for your API and a server-side runtime for executing queries by using a type system you define for your data. Okay, so what makes it so special? It's different than other API specs like REST in that you can query for only the data you need and all at once using a very expressive query language. Here's an example of a query for the name of the current logged-in user. You get everything you asked for and nothing more. The response looks something like this. Holy rusted metal, Batman. However, this concept brings new security concerns. But before we go over those, I should mention, GraphQL is not magic. All existing API security concerns still need to be considered. Wow, that's a lot of words. Unfortunately, we don't have time to go into all of these, so just keep fighting the good fight, and let's talk about some security concerns that are new or different in GraphQL. These include schema design, introspection, input validation, authentication, authorization, and operation limiting. Let's go over each one. Schema design. With great power comes great responsibility. Give all the data. Hold on there. Just because we can expose all of our data doesn't mean that we should. Instead, we should design a schema that exposes only what clients need. Then grow the schema as our clients' needs grow. When possible, I avoid tools like GraphQL Compose that generate a schema from a source of data. If we're not careful when generating our schema, we might inadvertently expose sensitive data. Notice the password field on the user type is now exposed like our friend here. Obviously, this is a contrived example, but you get the idea. Handcrafted is better. There are some exceptions, but generally, from a security perspective and from a schema design perspective, it's better to manually craft your schema based on your client's needs. I could talk about schema design forever, but let's get back to security. Introspection. GraphQL APIs have some pretty good built-in documentation. You simply send an introspection query to the API, and the API responds with a JSON description of the schema, including all available queries, mutation, and fields thereof. This JSON description can be processed by tools like GraphQL and Playground to provide interactive documentation. It's for developers. Introspection is intended to be a tool for development, and by default should be disabled in production, unless we have a public-facing API, in which case developers only have access to our production API. It's likely that we may not be around to help everyone integrate with our API, but we can solve this by enabling introspection in production and allowing developers to use the previously mentioned documentation tools to better understand and integrate with our API. However, it's possible that our schema contains information that should not be available to everyone. That's okay though, because we can hide elements of our schema using a custom directive and middleware that scrubs the response before it goes out. Our custom directive might look something like this. Notice the delete hero mutation is marked with a hide directive because only admin needs to know about it. There's also a node module called Apollo Server Restrict Introspection that does the same thing. Some things we may want to hide include capabilities that should be limited to admin users only. It's not necessarily insecure for a non-admin user to know about these capabilities, but it's certainly not information that we want in the hands of an attacker. When developing a new feature, we may only want a select group of clients to have access to a new query or new fields. We might also be using private directives that were never meant to be seen by anyone. Introspection is a powerful tool. You can use it in production if you need to. Just remember to cover up. Let's talk a little about input validation. This guy seems to be doing it as close to the user as possible. GraphQL actually has some built-in input validation by way of scalar types. All input to and output from a GraphQL API must be in the form of scalar types. That means that a super advanced SQL injection attack like this will simply result in an error for not having an integer as the limit argument. We can also create our own custom scalars for more advanced use cases. For example, we might want to ensure that a string is a valid email address before doing anything with it. In that case, we would simply define and use a new email scalar type in our schema like this. Then we just need to provide implementation that does the actual email validation. We can do this using the GraphQL scalar type class from the GraphQL npm module. The scalars alone may be insufficient for some use cases. Maybe we only want to allow really short email addresses, for example. Our next thought might be to simply add some extra validation code to our resolvers that check the length of the incoming email address. I would recommend against that, as it's best to keep our resolver logic as simple as possible. Instead, we can create a max character directive to do the same thing. Now it's reusable and it's applied in our schema, where it can also serve as documentation. Like our custom email scalar, we simply need to define the new max directive in our schema and provide an implementation for it. However, it's possible to avoid having two separate types of input validation if we simply make better scalars. We could provide a short email address scalar that does both validations. This makes our schema even more clear. If you don't want to write any custom code, there's a pretty good open source directive that can get you started called GraphQL Constraint Directive. Authentication. To be clear, authentication and authorization are two completely different concepts, kind of like DC and Marvel. Authentication is the act of verifying the identity of a user and determining if they are logged in or not. Here's a simplified example of token-based authentication, whereby a user sends their credentials to a login endpoint and receives an access token in return. The user can then use this token to identify themselves and access protected data. We can avoid any new security concerns related to GraphQL and authentication by using standard token-based authentication, like the previous example, and keeping it out of the GraphQL layer, which would simply expect a decoded token to be available when a user is logged in. Like this example, where we are passing our decoded token from rec.user to the context object using Express GraphQL's context option. Now we can access the logged in user object anywhere in our GraphQL layer, like the resolver function, for instance. Well, let's see how this ties into authorization, which is the act of determining if a user can access certain data based on their role and any system permissions. Authorization, like everything else, can be implemented in a number of ways. But like before, it's best to keep it out of the resolver layer. We want to keep our resolvers as simple as possible. Using directives for authorization or moving it out of GraphQL completely are both good options. To authorize with directives, we simply add our custom authorization directive to our schema and use it on some types and fields. And again, like the other directives, we just need to define our auth directive in our schema and provide an implementation for it. Now only admins can see our hero's weaknesses. You want to be careful about authorizing at the field level though, because one day our schema might look like this, where all our hero's weaknesses are protected from within the hero object. And the next day someone makes a change, and now our hero's weaknesses are exposed as a top-level query with broken authorization. This kind of exposure can be avoided by authorizing at the object level, where it's closer to the data that it's intended to protect. It looks something like this. Now our hero's weaknesses are protected at the hero level, as well as the top-level query, and any other place it might appear in our schema because it's co-located with the data it's protecting. If instead we want to keep authorization out of our GraphQL layer completely, then we can use a module called GraphQL Shield. It's a permissions layer that is loaded as a middleware, so our schema can remain as simple as possible. It's a powerful tool and is worth checking out. All right, let's move on. Operation limiting. To protect against denial of service, brute force, and other attacks, traditional endpoint-based APIs use a technique called rate limiting. This is accomplished by configuring a server to limit the number of requests per minute allowed by any given client. This is still helpful for GraphQL APIs, so we want to keep using the rate limiting mechanisms we already have in place. However, I titled this section Operation Limiting because GraphQL is different. With something like a REST API, you can simply assign each endpoint a rate limit because the cost to run that operation can be predicted. In this simplified example, we know the hero's endpoint will always make 2 subsequent downstream calls for data, so we can easily measure the cost of a request and set our rate limits accordingly. Whereas the cost of a request to our GraphQL endpoint can't be measured that way because it's based on the operation and not the endpoint. Consider that these 3 different queries will all be sent to the same GraphQL endpoint. On top of that, the flexibility of GraphQL makes it difficult to measure the cost of an arbitrarily constructed operation. To make the cost of operations more predictable, we could restrict the operations that are allowed to be executed against our API to ones that we know our clients need and are safe. There is a really nice out-of-the-box solution for this. It's a feature in Apollo Studio Enterprise called Operation Safe Listing. However, it can't be used in public APIs due to the fact that clients are allowed to construct arbitrary operations. Enter depth limits, a simple way to limit the cost of arbitrary operations. We can use the GraphQL depth limit module in Node to specify the maximum allowed depth for incoming operations. Any operations that are too deep, like this malicious query, will simply result in a depth limit error. What if a query is too broad, though? Operations have breadth as well as depth. Because there are multiple dimensions that operations can span, we need to find another way to limit the cost of our operations. If an API is simple enough, then depth limits alone might be sufficient. But for more advanced schemas, we can try to measure the cost of operations based on which fields and types are being executed. Luckily for us, there's multiple Node modules that can help us set limits based on complexity. Here's one called GraphQL Cost Analysis. We just need to configure the maximum allowed cost for our operations and add it to our validation rules. Then all we need to do is add the cost directive to individual types and fields. These complexity values can be tuned over time, and there are more advanced options for things like multiplying complexity based on specific arguments. If all else fails, we can rely on tried and true request timeouts, which your server probably already has configured. It's worth it to check it out, though, because it's your last line of defense against any malicious operations that manage to sneak through the cracks. Before we end this adventure, let's briefly review what we went over. We talked about how to be careful not to expose sensitive data when designing our schema, and when it's appropriate to enable introspection, but also how we can hide elements of our schema from introspection if needed. We went over the benefits of GraphQL's scalar types and how to use directives to enhance input validation. We discussed the differences between authentication and authorization and how it's best to leave authentication outside of GraphQL. We also went into some authorization best practices and the different layers we can authorize in. Finally, we learned how to create a set of rules to safeguard our API against malicious queries, as well as denial of service and brute force attacks. If you were feeling a little unsure about the security of your API, or never really bothered to dive into it before, then I hope this talk has cleared some things up and help you feel more equipped. Thanks again for joining, and stay safe, everyone.
Thank you, Joey, so much. If you have any questions for Joey, go ahead and drop them in our comments. He'll be able to get back to them as soon as he can. We do have a little bit of a break now, so if you are in the Pacific time zone, grab some lunch. If you're not and you need a snack, do that as well, and we will be back in about an hour and a half. Thanks again, Joey.
Thanks, guys.
Bye.
Testing my audio. Can you hear me? Great. All right. All right, we're just doing a quick sound check, and we'll be starting in about 7 minutes. So I'm gonna start adding folks. Hi, Josh.
Hello.
Okay, looks like we can hear you.
Hello,
We are
hi.
live, we're doing a live sound check. Hi, Manjula, and hi, Ryan. And
Hello.
I want to just, can we hear you? Hi, John.
Hello.
Summer, can you just say hi really quickly one more time just to make sure I can hear you? Okay, great. We'll add Shruti and Mark too, which I do believe you guys have done this now before. Great. Okay, lovely. So everyone, we will see you all in just about 5 minutes to get started with the community panel with all these lovely folks. And we'll see you soon. Okay, just adding everybody back. And are we missing someone? Are we missing Manjula? We are. Oh no, she's right there. Okay. There she is. All right. Well, welcome back, everyone. We're super excited to start the community panel now. And I'm going to go ahead and let Shruti, our MC, introduce, and we'll take it from there.
Hey, everyone. So happy to see you all here. I hope you had a good lunch break. Your tummies are full. Why don't we go ahead and start introducing ourselves? John, I'll start nominating you first.
You said John, right?
Yes, I said John.
All right. Hey, everyone. My name is John Wong. I'm a staff software engineer at Coursera. Been using GraphQL for 5 years now, basically since it came out. So definitely happy to be here, and I'm calling in from San Francisco.
Manjula, you want to go next?
Yeah, sure. So hi, everyone. I'm Manjula, and I'm working at a digital bank called N26 as a web engineer. So I work with React and GraphQL for about 3-4 years. Yeah, that's about it.
Ryan, you want to go next?
Sure. Hey, I'm Ryan, and I work at Prisma. I do DevRel stuff there, particularly focused on GraphQL, but also more widely with Prisma as well. I've been working with GraphQL for maybe 4 years or something like that, 3.5 or 4 years, and I'm happy to be here with you all.
Summer, you want to go next?
Hi, my name is Summer Schrader. I work with FaunaDB on the product team. I've only started working with GraphQL since we started developing the GraphQL API. But I'm excited to be here.
Josh, you want to go next?
Sure. Hi, everybody. I'm Josh. I'm a senior software engineer at this.labs. And I've been working with GraphQL for about 1.5 years, 2 years.
And we all know Mark and Tracy, but do you guys want to give an intro as well?
Sure. Yeah, I'll go ahead. Yeah, my name is Mark Stewart. I'm a senior engineering manager at PayPal. I've been working with GraphQL for 2.5 years.
Yes. And Mark, while we have you on the mic, would you like to just say a little bit about our sponsors, specifically PayPal and Braintree?
Yeah, sure. So I kind of said a little earlier, but yeah, we have, I think as of this morning, we have about 88 job openings related to GraphQL. So most of them are, remote in US and India. So yeah, if you're interested in any kind of full stack web developer positions or mobile developer, or even just back-end API developer, there's a wide range of roles that are open. So yeah, I definitely needed to say that. That's my sponsored bit there. Definitely go check those out if you're interested.
Yeah, and thank you so much, Mark, for supporting the GraphQL community and, coming up with this awesome event with us. And we're having so much fun with you. So thank you so much for that. So my name's Tracy. You can follow me on Twitter at LadyLeet. I am one of the co-founders at this.labs, and we love GraphQL. I feel like I was about to tweet this, but I'm definitely going to say that GraphQL is my favorite community right now. And I think it's because there's no framework war drama or anything. There doesn't seem to be as much internal fighting as I feel like some of the frameworks right now are having a little bit of internal stress. But I just love that everybody, regardless of framework, can just unite around GraphQL. So maybe GraphQL is the thing that holds us all together, quite literally. And then I also wanted to just pass the mic back off to Summer really quickly because her company Fauna was so nice to also sponsor part of this. So Summer, do you want to say a little bit about fauna? I believe you're muted.
Sorry about that.
Oh, that's okay.
DB is unique because we actually have a native GraphQL backend, and our query language for custom logic is a functional query language, so they complement each other really well. It's also really easy to get up and running quickly because you don't have to provision the cluster or deal with any other kind of backend headaches. You can just focus on your UI, and probably most importantly, it has a very generous free tier. So yeah, please sign up today with the Data API for client serverless apps.
Awesome. Yeah, I've been really loving seeing Fauna invest in the community too. So it's really, really great to see. And I have a Fauna shirt, which I totally should have worn. Mark, you'll have to send me a PayPal or Braintree shirt so I can wear that too.
Sounds good.
So thank you so much, Shruti, for kicking us off. We really appreciate it. You've been an amazing MC. And this next part, this community panel, Mark and I will be leading. And Mark, I'll let you kick it off, I guess.
Yeah, sounds good. Okay, this is all going to be about GraphQL in production. We're looking for some, some battle stories, some kind of, some stuff maybe you wouldn't hear in a blog post. That's kind of the goal. So, yeah, I'm wondering, have you had any unique scaling challenges with GraphQL, or have you heard of any other companies? Anything that's unique to GraphQL, and how did you, work around those issues? So talking about like scaling issues, whether it's like efficiency, performance, stuff like that.
Can I go?
Yeah, go ahead.
So I think in my previous organization, we used to keep like a database mapper doc, like in order to scale, and since it was like large team, and we had to add and remove fields, so we had this database mapper, and after that what we used to do is anything that needs to be added newly would be added to this database mapper, and then we used to discuss and then basically implement the resolver. And also we didn't write the schema directly. We sort of used the code first approach, where we used to write our resolvers in the code. And then we use this something called as Nexus.js. I don't know if you've heard. It basically generates, auto-generates the schema for you. So I think this is the one thing that we did, which was sort of a new for us. And definitely, I mean, we always make sure that, if we are kind of using the fields that are not to be used, we make sure that they are deprecated.
Awesome. Yeah, thanks for that. Does anybody have anything to add around, schema generation, or, yeah, like how do you all collaborate on the same schema at your companies?
I can chime in here. So we have a particularly interesting way of generating our GraphQL schema, where we auto-generate it from code, but we don't. We auto-generate everything. So anything that gets exposed in our REST framework gets automatically generated in GraphQL, which has goods and bads. The goods, you have GraphQL definitions for everything that you've defined. The bad is that you have GraphQL definitions for everything you've had defined. So there was no sort of process around sort of being more intentional about how we grew the schema. So maybe we had an internal field that got passed through to the GraphQL schema or something like that. So we've definitely held back a little bit on that and made sure that we're more intentional about it. But as we've grown, it's been tough to be consistent about what your schema, your field names look like, what things should get exposed and in what way, and thinking about how you evolve the graph, because ultimately you need to be able to change it very easily. And that's definitely been a difficult thing to do.
Yeah, I guess, does anybody have anything to add to that? Otherwise, yeah, John, I was actually wondering, can you tell us a little bit about, how you've evolved your schema, or really dealt with, breaking changes and things like that? How do you deal with that at Coursera? And, I'm definitely interested in the rest of the panelists' thoughts too.
Yeah, it's been a hard problem. We have clients in both web and mobile. And for web, it's a little bit more tenable to break the schema because it sort of gets refreshed immediately for the most part. And then for mobile clients, we have the long tail of installs, so we can't actually break those things that often. We really kind of subverted this problem by just avoiding it and saying most of the schema is append only, which is neither here nor there, but I think it's one strategy that we've used. So if something is, we're adding a new resource or something like that, instead of dealing with the switching between this old thing and making sure it's backwards compatible and all that sort of stuff, we just version the actual field name itself. So we have, because our schema correlates to our REST APIs, you get the same kind of V1, V2, V3, but it then means that everything is backwards compatible to new clients.
So also everyone who is listening in, feel free to post any questions in the comments and we will go ahead and answer them. So there were a lot of questions for the keynote panel, which we totally enjoyed. So feel free to post your questions there. I want to take you guys back a little bit with this next question. And just think about, when you first heard of GraphQL and you thought, oh my gosh, this is the coolest thing ever. I'm going to spend the rest of my life in this. I'm sure that's what all of you all were thinking. And after you guys actually were able to implement it in production, did your thoughts change? Or like what things did you, I guess, not expect after you were actually able to use GraphQL in production?
So I've got kind of a, maybe I can take that in a bit of a weird direction, but I use GraphQL in a client for the application of a client of mine that I spent before starting at Prisma. I spent maybe a year and a half building. And I found myself wondering at the end of it what the real value I was getting from this GraphQL powered application was, and that's largely because I was the sole developer on this project. And what I kind of came to realize is that it's nice to use GraphQL from a development perspective. It's nice to have like a nice API that I can go and introspect myself after. But I also found myself questioning whether or not it was a great idea to do it as a solo developer. And I think the reason I was questioning that was because the value of it, what I really started to notice was when you have like a team scenario and when you have multiple developers collaborating on the same application, that's where you really start to draw out a lot of the value from GraphQL. So by the end of that process, I was wondering if I should have just created a REST API. I'm glad I did because I've got other developers working on that same project now. And so it's nice for them to sort of pick things up and be able to use all the features that we love of GraphQL, be able to get a sense of the API just by introspection, etc. But from I guess what surprised me after going through the process for so long was that maybe there's a place where GraphQL shines a bit more, and maybe there's a place where it doesn't. I think where it really shines is when you have like a large team or large sets of teams all collaborating sort of disparately on the same product. That's really when it's going to shine, which bodes well in an enterprise setting, of course.
Anyone else?
I think, yeah, I have an interesting take on this one, which is like when we kind of chanced upon GraphQL by accident, it was used to solve a problem that we couldn't solve with REST, which is being able to jump from one resource to the other. So think of courses to partners to courses to universities to professors and back to courses, right? That kind of relationship's sometimes difficult in REST. So we found GraphQL as a really great solution to that. But once we really dove into the technology and understood the philosophy behind having declarative data declarations in the clients, it started opening up a lot of doors that we didn't think about before. And I think just that mindset of both having the client say exactly what they need, the tooling ecosystem around the client itself, it felt like no matter what the implementation under the hood was of the GraphQL server, GraphQL as a philosophy was allowing us to solve different kinds of problems, whether it was, we use GraphQL for one of our internal deployment tools, and we use it to sort of tie together a ton of different serverless type APIs. And in a typical world, that would be in this sort of monolith. But now we can actually just use those APIs as the sources of truth for everything, but the consumer doesn't need to know. So we keep coming back to GraphQL in different use cases and finding that, yes, this does help us solve our problem, even if the implementation is different.
Cool. I noticed we have a question from the audience. Let's see. Have people had remorse about adopting a particular GraphQL client? It's kind of a hot take.
I thought there was no holy war.
Be careful.
I mean, I can say like I've been using Apollo Server for some time, and I wouldn't say entirely remorse, but I really enjoy the hooks in React, and I really enjoy not using classes. And so when I implement right now with it's very class heavy, and using data sources, it really does force us to create classes as well and kind of conform to that structure. So I would say it's a small regret, but the value is obviously worth it, you know.
Yeah, internally at PayPal, we don't really have a standard of what GraphQL client to use. We just, usually people start off with plain old, on the web, fetch and plain old AJAX calls, but they quickly realize, okay, if I'm going to have a bunch of similar queries and things like that, I should probably batch them and, use fragments, dedupe them, things like that. Yeah, I don't know if anybody really has remorse about a specific client. I think you just kind of choose what's good. Usually we tell people to start out simple and discover those issues and then use kind of a full-fledged client like Apollo client.
I will say when we first started using GraphQL, we leaned really heavily into Relay, and that did inform our schema. I think that was sort of it felt strange for the client that we were using to inform the schemas that we were building underneath the hood. Actually turned out to be a reasonable decision. Like the Relay schema specification is well thought through, and they have good reasons for what they do. And so actually it helped inform our schema decisions as well. So I wouldn't say it's remorse, but it was caused by the client that we chose. We've since switched to Apollo client for a little bit more flexibility, but there's good reasons for some of the decisions they're making.
Awesome. Cool. Actually, one more question came in. So Ryan, let's see, Sean Grove has a follow-up question for you about something you mentioned. Sorry, Tracy. Yeah, could you highlight that? There you go. Cool. Yeah, so Ryan mentioned the benefits of GraphQL for teams, but would have preferred REST for a single, dev project. What are the downsides of GraphQL for these single dev projects? Yeah.
Yeah, I mean, I in retrospect, like I am glad that I chose GraphQL, and it was nice to work with. I think if there was any preference early on in that project to use REST instead of GraphQL, it was probably more so that GraphQL was newer to me at the time. So there was the overhead of learning it in a way that could be, put out to production, much like REST APIs that I had previously developed would be. So, so a bit of learning overhead, I think, was the downside there, and that would be the downside, I think, if you are coming from a REST background and you're a single dev, and maybe there isn't a huge need to be able to collaborate across various teams as a compelling argument to switch to GraphQL. So maybe speed of delivery is one of the upsides for REST if you're already in that world. But if you don't have that concern, if you've worked with GraphQL before and you're a single dev on a project, I don't think there's necessarily a downside to using it. But I guess the argument could be made that perhaps it contains a little bit more overhead than would be necessary otherwise.
Thank you.
I would just like to add something to the downside. So since we work at a bank, and we have like GraphQL as a middle layer, and having something as a graph interface could allow sending some malicious queries. So in order to do that, what we do is we limit the query depth to 6. And this is what works for us. And maybe, different companies can have different query depth. But I think this is one of the concern as well. You could possibly have something malicious queries. So this is one of the things that I would like to add.
Awesome. Thank you.
I think
All right.
also Summer has a question for the panel. So,
oh, we're at.
Yeah, I'm just kind of curious if you guys had any kind of favorite graphical user interfaces for editing your schema, especially really complex schema. It kind of gets back to the idea of evolving your schema over time.
I don't know about any, GUIs or interfaces for doing that very easily. It sounds like somebody should invent that.
I was going to say
idea.
that somebody needs to build this product now, obviously. Maybe it'll be you, Summer. Like just, 6 months later, introducing.
Sounds good, we'll use it.
I guess I have sort of ulterior motives for asking about that.
Yeah. I have a question as well. So at this dot, we talked to so many different companies, and GraphQL is definitely the hot thing, right? That everybody's talking about, especially in enterprise companies. But it's always a question of who owns GraphQL at these specific companies. So I would love to hear from you all. Is GraphQL centralized or distributed at your companies, and what have you seen work well and not well?
So
yeah,
go ahead.
So I think at the company I work, it's not mostly owned by certain group of people. It's mostly divided based on the verticals. So everybody owns sort of stuff. But yes, definitely when something is happening, you're adding certain fields to schema. It is we make sure that we communicate it to the other teams.
I think for us, where GraphQL happens in the stack really changes. So for example, even though our web clients are calling into the GraphQL schema, there's a whole world of GraphQL in the client itself. Apollo client, all of its the extra stuff there, Apollo Link REST, Apollo Link, all those other things that are happening in the client. So there's still some stuff happening there in the client side that the front end engineers are owning, and that's tying together our GraphQL servers with arbitrary REST servers or something like that. In the back end, we're generating our GraphQL servers from our REST APIs, and at each of those levels, we have different owners and different people who are sort of responsible for those sections. But what's nice is that flexibility, that the client can go ahead and add extra things if the server doesn't happen to have that available for us just yet. We do think, as we've planned out, okay, here are different ways that we want to evolve GraphQL in the future, that as the schema grows, it actually becomes harder to understand, and having some sort of centralized governance group would be something that's valuable. But we haven't been able to get sort of results from that process as of yet.
This is actually something that I've thought about for some time, because it's a philosophical question, I think, as well as who owns essentially how's the schema going to be defined and grow, and that's really what everything is built off of, is what's the schema going to be. And I think it's my opinion that I think the front end engineers should essentially own developing and creating their schema, because we're really trying to serve the front end and allow them to have that power to be able to say, hey, we want to develop this view or this new feature on this app, and this is the data structure we want our state to look like, and so we're going to write the schema for it. And then the backend team that implements on the server can take that and develop the resolvers accordingly. But essentially, I think that and I've had varying experiences with this because a lot of times I work with people that haven't done GraphQL yet. So the front end engineers don't really even know what power they have available to them. You know, they're not used to being able to define what their responses look like. They're used to saying, what APIs do we have to call? And so training them into that to understand and think like you actually can define the way your response is going to look like to fit your state when this view renders is huge. So that's kind of my personal take on that whole, the way things work.
Awesome. All right, looking at the comments, we have a couple other questions. Let's see. From Fubar, how do you coordinate SLOs or SLAs to make sure that various services don't prevent critical queries from rendering? So I think, yeah, so we haven't really solved this at PayPal too much. Like we haven't really set a higher level timeout for kind of queries, depending on what's inside. We do define SLAs for different fields, and you know we surface that through documentation, and developers will kind of, you know, hopefully be well informed when they decide like how to chunk up their queries, you know, split them up into multiples or combine them. But we haven't really discovered a great way to kind of coordinate this. Totally interested if other people have other ideas they could share.
This is kind of cheating, but because we have SLOs on the applications themselves, the front end applications, which are responsible for constructing the queries, and we're doing server-side rendering, because we have the one point where we're making this chunked GraphQL query down to our GraphQL server. They're ultimately responsible for pulling together the correct query. So if a part of the query is slow, then you're going to take it out of it and take it out of that big query and focus on the part that you need for rendering the page. I didn't solve anything about coordinating the SLOs. I just sort of bubbled it up to the one point where you could manage that.
Something I'm curious about, has GraphQL changed the way that your teams work together? Maybe not even just engineers, but maybe, you know, product managers and engineers. How has that changed the way that you all work, for better or worse, but hopefully better?
I can say that one of the things, you know, we were implementing GraphQL with one of our clients, and one of the biggest changes of how the front end team and the back end team worked was that the front end team now felt much more empowered and much less stressed out about having to ask about different things or figuring out, you know, why on earth this API returns, you know, a million different things I don't need. And, you know, they were doing a lot of work in the front end to try to work around, right? So there was just a lot of stuff that was happening on the front end that didn't need to, if the APIs were, you know, working a little bit better. So that I found really interesting. I felt like the teams were really able to start working more effectively together, and the front end teams again were just much less stressed out.
I was also going to say one of the main. I was saying one of the main things that I see is that the front end team gets to develop more UI much quicker and doesn't have to think about, you know, data wrangling and whatnot. So from the overview, like that's been a benefit.
From my direct team, it's changed what was previously front end and back end responsibilities to being something where someone can operate full stack and do that very quickly. So we don't have that distinction on my team anymore because of GraphQL.
I think in our case, it's more like, since we are building BFF, which is like, you know, backend for front end, we need to collaborate a lot with backend, and backend has to be ready prior with the schemas, and then, you know, the front end starts working on it. So Moreover, it's more like, the backend has to work like really much ahead in time than the front end does.
Awesome, thank you. All right, let's see. We have actually three more questions in the chat that we haven't answered. So I'm going to scroll up to Harish. How do we break up GraphQL service-like microservice architecture? So I guess, do you have any, is when it comes to microservices, is GraphQL kind of unique compared to REST? So do you have any tips to share there as you're kind of breaking things up?
I was going to say, I think that any type of microservice structure you want to do, like I would say domain specific, maybe. And, ultimately we're just, executing a function. So just spin up the various containers that contain that specific domain of, queries of the resolvers and for mutations, and just, I usually try to do domain specific architecture. So, but like I would say there's nothing special about it other than like anything you would do with a REST API, you can implement with GraphQL. Does that make sense?
I think so.
I think since GraphQL ends up being one big schema in the end, you have different layers of abstraction where you can break things apart. So if this question is more focused on the actual runtime, then there are things like federation that help you. But other tools that we've used that have made it easier to organize our GraphQL services, like their individual domains and tying them all together. GraphQL modules has been a huge boon for us, and something that makes it really simple to understand where certain parts of the schema are and how they all tie together. So ultimately, we're still pulling everything together into one server, but we don't need to think of the entire schema in this one gigantic file or anything like that.
Awesome. Okay, one more question we'll take for now. Okay, cool. Yeah, it's from Sean Grove. Has anyone, he goes, besides Twitter, implemented persisted queries a la Relay as a method of locking down their API in production?
Yeah, we did this to an extent. We used Apollo servers persisted queries, and it works fairly well. You don't need to pre-register your queries or anything like that. Sean knows this, but for the other people who are listening, you should not use that as the only way of locking down your API. But it is one of many tools that you can use to lock down your API in production. I'm curious what if there's an underlying question there, or if it was just that people having experience using it.
Cool, Sean, if you're listening, yeah, if you could kind of clarify your question, we'll come back to it. All right, so we asked this question for the keynote panel. I'll ask it again, kind of looking for some interesting stories here. Do you have an interesting production battle story that you could share? Just something crazy that happened that you didn't expect, and how did you overcome that? Things that you could share.
Oh man, we're gonna have to ask the audience. Feel free to post your stories in the comments below.
Yeah, I think for us, we didn't expect, we didn't expect the fan out of calls internally to be so much. Didn't expect these queries to just fetch from tons of data sources. So it actually caused a lot of pressure on our HTTP client that we use internally for talking to other services. And so it actually forced us to, be smart about connection pooling and reusing parts of HTTP basically. So yeah, I guess if anything, it forced our client to be a little better and probably optimized other stuff too. But that's something we didn't really encounter until it was like, whoa, we're making a lot of calls to these services. And, you know, our Node.js event loop is really busy, just waiting on things. Not sure if anybody has anything else like that.
So another question I'd like to actually ask is, you know, related around, you know, any custom tools or processes that you have built internally to help you with GraphQL. You know, I always love it when companies figure something out that's hard and then actually release that to everybody else, and then the community starts adopting it. So I'd love to hear if you guys have, you know, any custom processes, and also like how were those, you know, have they become standards and how? So it's very open-ended. I asked like 3 questions at once.
We don't have as such any custom tools, but yes, we definitely use this GraphQL Voyager in order to generate an overview of what the query and the mutations and the schema relations look like, which, you know, gives a broader overview as a developer to see what's going on. I mean, definitely we don't have anything internal as such, but yes, we keep on using GraphQL Voyager. And I mean, to my side projects, I've definitely used a lot of query builder for databases, for example, Prisma and Knex. So that's called KNEX. I mean, these are the tools that I've used so far.
I could speak to maybe not process related necessarily, but like some of the tools that Prisma has put out, which are very nice to use if you're into like a code first approach to writing a GraphQL API. So there's this whole Nexus library and framework that Prisma is involved with, which is a bit of a different approach to creating a GraphQL API if you're used to doing a schema first approach, where you would use the schema definition language to create the shape of your API and then tie up some resolvers to that schema. You do all of that in kind of one step with Nexus. You use code to define both your schema and your resolvers in code, and it's very nice because you get a kind of type safe GraphQL API this way. So if you're working in TypeScript, you get the benefit of the code first approach, meaning you don't have to manage your SDL and then your resolvers, and then you also you get types generated for you. You get a GraphQL schema generated for you, and lots of things that happen automatically to ease the process of building your API. So if you're interested in that, you can check out Nexus, and it's a very nice tool to work with. We've had some really good success stories, people putting it into production and seeing great results with that.
Yeah, a related question. I'm wondering, when you all introduced GraphQL to your companies, did your ops teams or anything, you know, the people watching the production systems basically, did they have any issues with it? Did you have to build any kind of like custom tooling to make it work in your ecosystem? Yeah, just wondering if ops or other teams kind of had issues initially. Or if you all built any kind of custom instrumentation or visualization tools, anything like that, I think are kind of things I'm interested in hearing about.
We definitely had to do a lot of instrumentation to make we were hitting the same fan out issues that you were hitting, Mark. So had to build in a lot of tooling to make sure that we were keeping track of that fan out, and making sure that we had to, for example, we enforced that all of our REST APIs had to expose a multi-get. So instead of spamming a service for 1,000 whatevers, you hit it once with 1,000 IDs or something like that. So we had to enforce conventions early on to make sure that we weren't hurting ourselves in the process.
I love this next question that Derek just asked, which is, What was it like creating community internally at your companies so that GraphQL efforts were streamlined and well orchestrated? And I feel like this is a lot. PayPal really has spent a lot of time and energy on this.
Derek actually used to work at PayPal, so maybe it's not a good it's not a good answer. Hey, Derek. Yeah, I'll let someone else go, and then I can follow up.
So we took the approach of making it as easy as possible to opt into it rather than forcing people to use it at the beginning. So clients could use the REST APIs, or you could use the GraphQL APIs for the same thing. And because, again, we're auto-generating this GraphQL from the REST APIs, ultimately the source, the underlying source of truth is the same. But from a developer experience standpoint, the GraphQL is just way better. You could go between different resources. You got type generation. You have this, GraphQL graphical or other tools like that. And so people naturally chose that rather than having to sort of make people use it. So that's been a pretty good strategy for getting adoption, is allowing them to make that choice in the beginning.
Yeah, at our company, the community kind of grew, organically. It was just, teams sharing successes and kind of downfalls and stuff like that, and then it just kind of picked up. But I'm kind of looking around at other companies, and companies that have central GraphQL teams or kind of GraphQL infra teams or standards teams, they seem to be the most successful. So yeah, I would highly recommend that, even if it's 1 or 2 people, somebody to just constantly think about doing GraphQL the right way and helping out other teams. That's probably how you're going to get the most success. But yeah, as far as community, yeah, all organically. It wasn't top down or anything like that.
I find a lot of companies tend to do this with technologies, and I've seen it a lot in the GraphQL. Igor mentioned just creating a GraphQL squad Slack channel, which is a great idea. But a lot of companies kind of have like the leads or the implementation leaders or the groups, like the architect groups of these different types of things. And I think that's actually been quite useful and helpful, right? Because it kind of is that top-down approach in a sense, but then everybody who has questions can kind of go to one sort of single source of truth in a sense. And, that way best practices are developed, because I don't know if any of you have run into this issue before of, large company and just sort of like everybody adopting the same technology and everybody having different standards and their own best practices and not finding out about it for a while. Has anybody run into that issue and overcome it in any way?
I've heard this story from a few companies, and at Coursera this happened as well too, which is at the beginning we really had to have guardrails on how you used GraphQL, because it was really easy to not do it the right way or break underlying systems. So we wrote some really solid docs on how to structure an application with GraphQL, how to do certain things in different ways, using fragments and things like that. And we would get tagged on a lot of these PRs. So certainly not scalable over time, but in the beginning, we grew these GraphQL champions throughout the organization that could review code and talk about why we were making some of these decisions.
I think, Summer, I love it because you're on the panel, but you also have amazing questions. So I didn't know if you wanted to ask the question that you had.
Yeah, I was kind of curious if anyone had any kind of experience running into the N+1 problem with how they're at Fauna, we're not really writing an app in GraphQL. We're developing a GraphQL API. And we have sort of a unique way of solving the N+1 problem. And I'm just kind of curious about the extent to which that even matters to people. I'm wondering if any of you have actually run into any kind of problems in production or development where you've been like, oh, that's because of the N+1 problem. It kind of relates a little bit to one of these community questions. It was, is there a limit on the number of fields for query schema as best practice. And in my mind, it seems like it would involve more the way that your schema is organized than necessarily the number of fields, and the extent to which we run into problems with having to make round trips to the server versus what you run into with over and under fetching with a REST API. So we're just kind of curious about whether or not you've actually run into the N+1 problem.
Yeah, we hit this all the time. We enforce that like any new data source, any like new endpoint that we're hitting has to have a data source in front of it, because it's really, really simple to have one nested field on a list of items and having to call that thing like a million times. So we watch that. We get throttled all the time because we use these underlying third-party APIs as our sources of truth. We do have an intermediary cache layer, which does save us from a lot of these things, but it's definitely a problem that's always present.
Yeah, similar to what John's saying. Actually, everyone's going to learn about this in the next talk by Vishaka. But yeah, we basically memoize or cache those internal requests within the same request, if that makes sense. And then we also kind of have this key value store and stuff like that to throw things into. It's definitely not perfect though. I feel like maybe the most ideal is to maybe use something like Apollo Federation, where it like intelligently kind of splits up subqueries and things like that. But yeah, this has gotten us pretty far so far. Things are working pretty good.
Okay, yeah, I mean, if that's the case, you might want to look into Fauna, because I don't think anyone else has the solution we do. Other providers use batching, but because we have this functional query language, FQL, that complements GraphQL, we can just map them one-to-one. So it's not really an issue. I think that's one of the most unique things we have to offer. And it's good to know you guys run into that, so we should probably pump that up a bit in our marketing material. Thank you.
This is actually, at this dot, we've been hiring a lot, and we do a code exercise, and I can't tell you how many people, it's like, they do not solve the N+1 issue. Like, I see that like 50% of the exercises. But anyways, so thank you so much, panel, for coming and joining us. I mean, this was so awesome. And, all these folks are super involved in the GraphQL community. So if you're looking for more GraphQL content, feel free to follow them on Twitter. Feel free to keep asking questions in the comments. Don't forget that PayPal and Braintree are hiring. So how cool is that? Enterprise company using cool new tech. But Mark, you've never told anybody how to actually apply for a job.
Oh, right. Yeah, so go to paypal.com, scroll all the way down, and in the footer, there's going to be a jobs link. Click that, type in GraphQL, and you'll see all these different positions. So there's a lot in different locations and things too.
That's awesome. Yes. And you can also stalk, Mark, find him on the internet somewhere if you have any questions or whatever. If anybody's looking for a job, they can always feel free to email me too. And I'm always happy to help out the community. So anyways, well, thank you again, everybody. And we will be back in just a little bit and get started with the next talk. So I'm going to remove everybody, and thank you again so much for joining.
Thank you.
Thank you.
Okay, so next up we are going to have Vishaka, and she is going to be starting in just 12 minutes at the top of the hour. So feel free to grab a bathroom break, but stay tuned because this is going to be a really, really interesting talk. So I'm going to do a quick sound check as well. This is going to be live, but y'all can ignore us for now. Vishaka, I just added you to the stream. You can test your audio now if you like.
Hi. Thank you.
Yeah.
Are you able to hear me?
Yes, and we're just doing this live. So do you have slides? Do you want to go ahead and...
Yes.
Mm-hmm.
It's the Just trying to make sure the lighting, yeah, okay. I do have slides with me, but when I like play them, it takes my entire screen. So just trying to figure that out so that at least I can see my Chrome tab where the live is happening, and
you should be able to, when it says share screen, you should be able to share only one Chrome tab.
Yeah. Are you suggesting that I open the presentation in Chrome instead?
Did you use Google Slides or Keynote or?
It is a Keynote.
It's a Keynote, okay.
So,
you should be able to share just the Keynote.
Yeah, see, I am trying to select my application window now, and I'm trying to share that.
Yep, I can see it. I'm gonna add it to the stream really quickly.
Yeah, but what's happening is that now I cannot see you. Like it took up my entire screen space, so I won't be able to. I mean, I can present this way, but I won't be able to see any incoming comments.
Oh, that's okay.
Okay.
You know, yeah. I mean, you can do comments after if you like as well.
Okay.
Yeah.
I don't know. I have done this similar presentation before online, and I think I was able to just present. I'm trying to see still if there is any way. Says Keynote.
I don't know if Shruti has any advice, but Vishaka's trying to present and she can't see her Keynote. It's a Keynote slides and the Chrome tab at the same time.
Vishaka, you might want to try switching your screen.
Switching screen?
It just did it for me.
It doesn't look like you're sharing anymore.
Oh, yeah, I stopped the sharing. I think
Okay.
it just switched the screen, so I stopped it. Let me try and share it again.
Nope. We lost her. So is that picture creepy in the back of me?
I think it's cute.
My husband says, you know, you really got to change that picture, especially if you're on calls. I'm like, who's going to care about a creepy doll staring at
Well, actually, it is kind of creepy, but I think it's cute.
Hi, welcome back, Vishaka.
I think I just went offline for a second. I don't know what's happening.
Yeah.
Wow. Okay. It's showing the entire screen.
Vishaka, do you want to show me on Slack?
What's that?
Do you want to show me on Slack?
Show me what?
Do you want to debug this on Slack?
Sure, yeah. Let me just stop my cam and
Welcome back, everybody. We are just about to get started, and I'm going to go ahead and add Shruti and Vishaka to the stage. And Vishaka, I don't think your video is on in case you wanted to turn it on. So this is going to be a really awesome talk. And go ahead and... Vishaka, are you there? I think you might be muted. There you go. All right. And I think your video is not on either, in case you wanted to turn your video on. There we go.
Hey everyone.
Cool.
Are you guys
Well,
able to see this presentation as well as me?
yes, we are able to see everything, but we'll let Shruti go ahead and introduce you first. Most important thing.
Of course. Hey everyone, welcome back after the break. I don't have music this time because I didn't get any song requests, but that's okay because I have a dev joke. Since we just came back from lunch, I have a question for all of you. Why lunch themselves? The chat is a little bit delayed, so I'll give it longer. Why do front-end developers eat lunch by themselves? Tracy, you were front-end developer, right?
I'm just like, is it because they're first and nobody's there? Is it because they want to sit in the back? No, that would be back-end developers. I don't even know. What
That could be another joke, because they're back-end developers.
Yeah.
Let's see if anybody in chat has an idea.
We need more dads so that they have the answers to the dad jokes. We call these dad jokes, although it's everybody jokes. But the question, can you repeat the question?
Why do front-end developers eat lunch by themselves? Because they're the only ones with... Oh, I like that. I like that a lot better than my own answer. They seem to create a lot of breaking changes. Does that cause... Wait, that's probably not the answer. Okay. Front-end developers eat lunch by themselves because they can't join tables. Igor, you got it.
Oh, that was good. That was good. Because they can't join tables.
All right. So I am really excited to welcome Vishaka Singh. Vishaka is going to be talking about building a faster checkout experience with GraphQL at PayPal. Vishaka is a software engineer at PayPal, where she works to make the checkout experience faster and better. She also loves spending time meditating, baking, and experimenting with makeup. It's all yours, Vishaka.
Thank you for introducing me, Shruti. After like 100 tries, I hope you guys are finally able to see my screen properly. Hopefully, I'll get started. All right. I work as a software engineer right here at PayPal. We started to use GraphQL over some 3 years. And ever since our adoption, we recognized a lot of benefits, not only with respect to the performance, but also developer productivity, and which brings me to talk about how we are building a faster checkout experience at PayPal with GraphQL. On the screen here, you're seeing a lot of different PayPal buttons. These are the PayPal buttons which lead you to the checkout experience. I don't know about you guys, but I cringe every time I look at them. They were built several years ago. Some of them were created by us. Some of them were created by merchants hoping to see optimize their experience. And some of them, I think, should have never seen the light of the day. But then, since that, the good news is that we have completely re-architected our PayPal checkout integrations. We open sourced a bunch of libraries which build truly cross-domain components. You all can check it out on these two repos on the screen. Sorry, these two repos on the screen, and they actually brought a lot of different advantages. Pixel perfection was one of them. No matter which device you're on, it's always going to bring you these crisp images. Also, we ourselves built a lot of different variations of these buttons, so we no longer had to worry about those terrible looking buttons anymore. Also, we sandbox these buttons inside an iframe, so we didn't have to worry about merchants code breaking us or we breaking them at the same time. So before I talk about how GraphQL fits in the picture, I would like to give a foreground on what we actually do. We build JavaScript payment SDKs for the merchants to drop on their website. So what it does, it Webpack bundles the entire script, which is required to render the payment methods, the checkout experience, and ships it to the user's browser. Once you see that PayPal button, you log on, get redirected to the PayPal, pay for your stuff, and get back to the merchants. On the screen, what you're seeing here are just a few lines of code. Between the script tag on the top of the screen is this one URL which gives you access to this entire code which is required to render these payment methods and the checkout experience. Now this entire rendering path or the rendering process needs to happen, our target needs to happen under 200 milliseconds, because that is kind of an average time a merchant's website loads with other items on the page. So we do target for a response time of under 200 milliseconds. Also, additionally, this application is a high volume application and it receives close to 100 million requests a day. So we kind of have to do a lot of packaging and bundling in a very, very short period of time. Next up, so I want to talk about the problem, what problem we were trying to solve using GraphQL. So whenever you are on a merchant's website, and if that merchant is offering PayPal, we want to be able to offer a customized checkout experience, which not only is this branded PayPal checkout button, but also various possible other regional payment methods, depending on which country you might be in, or a customized checkout wallet on your merchant's website. So the problem at hand here was to decide what all this particular buyer could see and Webpack bundle all of the code for specifically catered for this buyer and ship it back to the user. Now, to do this under 200 milliseconds, we needed a decisioning layer which would do the heavyweight lifting for us. So a bit of a history here again. We had a REST API which did something similar for us before, but as our number of partnerships grew and as this entire thing became basically scaled, the code was kind of spread around our code base, because oftentimes you have to depend on downstream API services to have those changes in time so that you can actually query for it. And as things started grew in size, we just had a better motivation to move all of this logic on to a GraphQL server. So we'll just go quickly over how the schema looks like and what we actually ended up designing. At the root level, we have the name of the query, which is the funding eligibility, which takes in a bunch of arguments. Now, these input parameters totally depends on what merchants provides
onto what kind of integration they would like to have, but also a lot of information, user information, whatever we could collect from a user's browser, which is typical, such as IP address or locale, their locale, or the cookies or the user agent. At the next level are the different types of payment methods which we offer today. Now, this is an exhaustive list of all the payment methods. And at the third level are the descriptors for each of these payment methods, right? So whether that payment method is eligible for a session, whether it's recommended, the reasons behind why it is eligible or not, and other factors. Now, this provides a lot of benefits. As you guys might know, a GraphQL query is executed in a top-down breadth-first fashion. This feature was very, very important for our API's performance, because what that means is that each of these fields or each of these payment methods, which are backed up by their own resolver function, can execute in parallel. So if you are trying to retrieve eligibility for, say, 10 different things, all of their logic and execution can happen in parallel. For those of you guys who might require a bit of a refresher, a resolver is a function which basically does a one-to-one mapping between the function and the field. So it can fetch data from different sources, different downstream API services, and can return different kind of values like null, arrays, scalar values, etc. One of the other benefits of which we could reap out of using GraphQL was that different clients can choose to request for different payment methods, not necessarily all. So you can have different client applications which are making requests to the GraphQL server, and through this they can control the size of the data they can query for. Also, since each of these resolver functions are independent for all of the fields, the implementation details stay pretty isolated. What that meant was that the entire inner sourcing and it made it pretty easy to inner source and collaborate between different teams, where each of the teams focused on a specific payment method could come do their implementation, and it reduced greatly the risk of breaking anyone else in the process. Also, we implemented a bunch of caching techniques for similar APIs across different resolver functions, which I would be talking about in our follow-up slides. So ultimately, because of how we sandbox our buttons inside an iframe using those cross-domain components and using GraphQL on the server, the merchants never have to reintegrate with us again, because anytime we have a new payment method, we can ship it to the user's browser. Because of this, we have been able to provide meaningful and impactful checkout experience through several different regional methods all across the globe. Next up, I'd just like to talk about some of the optimizations we did at the server side. Two different techniques, memoization and caching. Going back, memoization is just another type of caching where you are caching stuff in the context of a specific function. In this respect, it was the request lifecycle. So for one, for one request lifecycle, if a request to a certain downstream API service was made once, we could actually memoize it, and make sure that we do not call that same downstream API service again. So how did we implement this? This is pretty much the code we have today, where we create a cache key based off all the input arguments we get in that function and the name of the function. And we create a cache key of that. We call the downstream API service once and attach the result of this API service to the key hanging off the request lifecycles handler. So next time, if some other portion of the code is calling the same downstream API service, we would use the cache key and see if the value of this particular cache exists. And if it does, we just retrieve our results off of that. Next up was actual caching. Now, after a few of the releases, we realized that we did have some downstream API services whose responses we knew were not going to change for a few hours, and for some it was even few days. So we have a memcache Redis-like structure in-house in PayPal, which is called Mayfly. So we made use of Mayfly to cache a bunch of API responses. So this basically meant was that for different more than one network requests to GraphQL, we were ending up saving all of those responses. I'll give you an example. Let's say you're on a merchant's website, and we do use merchant's information to see if this particular payment method can be rendered for that merchant or not. We know that this merchant's account number is not going to change for almost forever. So we started caching all those information and created cache of that. So those multiple requests, network requests, would, if falling under the duration of that cache, can retrieve the results without having to call those things over and over. Now, this saved us a lot of milliseconds, and saving milliseconds was really important for us because it directly controls the rendering speeds of our payment methods and the checkout experience. For any API, instrumentation is very important because it tells us how that API is doing and what are the aspects which needs improvements. You might know on how many times a particular API is being called, but to have the ability to see what portion of your API is performing slow or is problematic, or what fields of your API response are actually needed by the client applications. GraphQL really helps in that aspect. It provides very powerful insights. You could, if you're using an Apollo server, you could use something called the tracing flag feature, where it lets you actually trace every minute granular fields as part of your schema. I'll show it in the next slide. So in this slide, the two different diagrams, the one at the top is the resolver duration. What you see here is the name of the schema and fields at different levels of the tree, and you can see the number of the amount of time it's required to execute it on an average, and also the number of times it was called per day. And obviously, we pipe all of that information in tools like Grafana and create graphs based off of that. There were 4 major benefits, I want to say, in bringing GraphQL on the table, not only for this project, but I think company across. First was the performance. Like we discussed in previous slides, this layer is on the hot rendering path of the checkout experience. So to have everything, decide what needs to be rendered and create a customized script for that and ship it back to the user's browser in a short period of time, we were able to achieve all of that kind of performance using GraphQL. And also, it goes without saying the kind of developer experience it brings. I think the migration process was pretty smooth. All of our team members were able to onboard themselves for GraphQL pretty quickly. Doesn't require a lot of prerequisite, and all of us were able to migrate our APIs to GraphQL in a short period of time. And also the entire flexibility it provides, right? You can query for what you need and nothing else. So you in our case, it directly controls the size of the data, because as the size of our response increases or decreases, it directly controls on how we ship our script, what all code we provide for different payment methods, and ship it back to the user's browser, which was, again, a very big win for us. And last was, I think, the entire evolution. So we no longer have to bump our APIs to different versions and make the effort of just doing I'm sorry. Yeah, so we don't have to bump our versions anymore or make sure that our older versions work. We can just incrementally make changes to our APIs and migrate to it. We also realized that in companies with more complex processes, teams are able to migrate much easier when you have small incremental changes rather than something really big. So this was a similar migration strategy we adopted as well, where we ran to a very small population and were still falling back on our older logics, and then increased our RAM to 100% ultimately. Also, at the same time, through all the instrumentation which GraphQL provides, we can migrate portions of our APIs, deprecate portions of our APIs pretty confidently. There is a deprecated directive which you can use, which sends information back to the client as its response that this particular field is going to be deprecated, and you can actually see what fields are being used. So there is no longer any requirement of overloading your API, so to say. With that, I would like to conclude my talk. You all might have already heard this throughout the talks from all the engineers from PayPal that we are hiring. And if you guys are interested to work, you can check out this link here. Mark actually put this blog up on Medium, and it beautifully talks about how our entire journey with GraphQL at PayPal. Thank you so much.
Oh my goodness.
Sorry.
Was I? Oh, that's okay.
I think you were speaking. I wasn't able to hear you. Sorry for that.
No, that was me. I was muted the entire time I was speaking.
Oh.
I
was like, what just happened?
Oh, no. I was just saying thank you so much, Vishaka. That was a really great presentation. And if anybody has any questions for Vishaka, feel free to post them on the chat. And, she'll be on for just a little bit, kind of answering those questions if you have them. And again, yeah, if you want to go work with Vishaka, then go work at PayPal or Braintree. I love, one of the things I love right now is that everybody's a little bit more remote friendly. So, you get to work with a much larger variety of people, and there's a lot more opportunities for people to join. So, but next coming up, we actually are going to have Brian. And so Brian is going to join us on the 45 mark. We're going to be doing a sound check in just about 10 minutes or so. So if anybody wants to take a bathroom break, go get something to eat, whatever it is, we will see you back here at the 45 mark. So see you all very soon. Doing a quick sound check here. Brian, I'm going to add you to the stream. Hello?
Okay.
Can you talk one more time? Your audio is really, really light. I don't know if maybe the your mic input is not the mic. I don't know.
Now this is my.
That's much better.
Okay. Yeah, it looks like it's not picking up anything.
Yeah, like right now I can't really hear you.
Yeah, that's the weirdest thing. Let me.
If you're talking, I can't hear you. No. Nope. Nothing. Shruti said, try turning it off and on maybe. And StreamYard also has a cam and mic option, so maybe you need to adjust the settings there. Nope. Still no. Hi again, Brian.
Can you hear me now?
Still really quiet.
Really quiet. If I turn it up, is that better?
Oh, yeah, it's much better.
Okay. Well, tell me if up or down. If that's good, because I just cranked up a lot.
Yeah, it's perfect. It's perfect now. Lovely. Awesome. Do you want to go ahead and see if you can share your slides?
Yep. Share screen. That is, now you're looking at my laptop.
Great. I can see your slides. Yep.
This is full screen.
Yep, looks perfect.
All right, excellent. So I don't know what, I just went into the Chrome settings
Mhm.
and allowed this microphone in front of me and the camera, because I was having trouble with the camera too. So
Awesome.
just for troubleshooting purposes, if you ever need to go through that with somebody else.
Great. Well, we're doing the sound check live, so just FYI. And we're gonna actually, get started. So I'm gonna invite Shruti, who is our MC, to the channel. Hi, Shruti.
Hey. Hey, Brian.
Hello. How are you doing?
I'm good. How are you?
I'm excellent.
I love the background. It's so colorful.
Thank you. I'm glad it's actually working, so hopefully it doesn't die on me in the middle.
It looks lovely. I love it.
All right. Excellent.
Well, all right. Hey, nice welcome back.
This is all working out.
Yeah. Well, Shruti, we're just at that mark of 5:45 where we're starting, so you can feel free to hop right into the introduction if you like.
All right, let's do it. Welcome back, everybody. We have been having technical difficulties in part 2 of this conference. So not a problem. There is no conference, especially virtual, which does not have technical difficulties. So it's all okay. We're getting past it. But I want to welcome Brian Douglas to this part. Brian is a developer advocate at GitHub, and Brian's specialty is GitHub Actions. So Brian, I'm going to be sending you lots of questions because I've been experimenting with GitHub Actions. Brian will be walking through some of the ways that he's been leveraging Persisted GraphQL in his talk, Persisted GraphQL, to create a smaller signature and reduce bandwidth utilization on client loading times. Take it away, Brian.
Excellent. All right, so I'm going to go ahead and share my screen and assume screen's actually, so I'm using Keynote, so it's taking over my whole screen. So feel free, Shruti, if something is wrong, just talk to me and I can listen. But yeah, thank you very much, DisDot. Thank you very much for the sponsors who allowed me to come and talk about this. I'm a big fan of GraphQL. I've been using GraphQL since the beginning, since it was like pre-alpha. I haven't had a lot of opportunity to do some advanced things until very recently, which is persisted GraphQL. So I'm very happy I'm able to be here and talk about this. If you want, you can follow me on Twitter. I did not get a chance to upload my slides up online, but I will tweet out my slides. So if you want to get a copy of these slides, feel free to just follow me on Twitter. I'll send that out later. But let's just jump right in. So persisted GraphQL. Before I jump in, I said let's jump in, but I'm really going to preface this with some maybe seem irrelevant, but I'm going to talk about this documentary on Netflix, which is the Hip Hop Evolution. I'm a big hip hop fan. I'm a big fan of just like finding out the history of it, because a lot of it I wasn't around for. Like I look good for my age, but I'm in the mid 30s. But also a lot of this hip hop is actually older than me, so it's nice to go back and try to figure out where hip hop came from. And if you aren't familiar with hip hop, this is like we also call it rap music as well. I assume maybe the audience is all American based on this time zone, but or North America. Well, this time zone basically. So assuming you know what hip hop is, apologies if you don't. But it really came from sampled disco tracks. So disco was this form of music back in the 70s. A lot of the dance and the clubs and Studio 54 came out of disco. And hip hop got started from disco tracks because there was a point in the late 70s where disco just sort of started winding down. So if you think of any other genre of music that you've sort of thought about or been a fan of since you've been alive, like maybe dubstep is one of them. Like they all have their sort of peaks and valleys, and a lot of them just never get out of the valley and sort of just die off. But Grandmaster Flash is a group that I got really into when I was much younger, like middle school. And they started going back deeper into their discography, mainly because of Napster. We don't have to go into Napster and what that is, but it was a way to basically get all the music you wanted for free and illegal. Don't do that, kids. Use Spotify or something legal. But Grandmaster Flash was a group that took disco tracks and made hip hop beats out of them. Grandmaster Flash actually in the Furious 5. So Grandmaster Flash is the leader of the group, and he was the DJ. And this group came out with this one song called The Message. And this message was, if you ever seen the movie Happy Feet, the first one, they actually featured the song in there, and it's also a song that a lot of people actually hear a lot, which is my brother's doing fast on my mother's TV, says he's watching too much. It's just not healthy. Kids in the daytime, Dallas at night. And then, yeah. So anyway, it has that flow, but the hook that you actually know is "Don't push me, cause I'm close to the edge. I'm trying not to lose my head." So anyway, that's a pretty deep song. It's a song about basically poverty in like literally the urban ghetto, which was New York, the Bronx specifically. And it was just talking about how hard it was just to get by and be still stuck in that sort of system, which was late 70s New York. And a lot of people know about like social rap, like commentary, social commentary when it comes to rap. A lot of people hear like, I mean, that song that came out last week, WAP. I mean, it's got a really good beat. Like whether or not that's For You, Nicki Minaj and Cardi B. Sorry, not Nicki Minaj. Megan Thee Stallion. Sorry, I know the difference. But yeah, anyway, great song. Pretty edgy, but this is more of a like actually talking about social change, which actually prefaced what we call gangster rap. Gangster rap is something that we probably heard through like the NWA movie and Straight Outta Compton. And one of the more prolific members in the gangster rap community was Tupac. And Tupac, he had his album, one of his later albums before he was shot and killed. So apologies if I sort of explained way too much or not enough. I'm a big fan of explaining history and giving details, especially when it comes to technical concepts, because there's a quote that I use all the time, which is Stan Lee: imagine every issue is someone's first issue. So if you've never heard of hip hop or Tupac, highly recommend go through the rabbit hole and watch Hip Hop Evolution to get more to the cliff notes, but I don't have time to go in everything. But I bring this up because Tupac had the song, which the hook of the song goes, "Ain't nothing but a gangster's party." So that was basically, the song was called Two of America's Most Wanted. Snoop Dogg, who's still around, was featured in that song too as well. And I bring this up because this song actually sampled that My Brother's Doing Fast on My Mother's TV. That beat, and the underlying beat of that song was actually leveraged in that song. So what I'm getting at is that hip hop, rap, disco, they've all been extremely sampled to actually produce the next wave of the genre and music. And I think the same thing if you were to dissect rock and roll, dissect power chords, and dissect all this other stuff, we all tend to always look back and create the next stage of the next evolution, basically, is what I'm trying to get at. So I say all that because I wanted to talk about rappers. I spent a lot of time talking about rappers inside of my GraphQL because I tend to wrap all my APIs, my existing APIs with GraphQL, especially if there's no GraphQL API too. So keep that context because I'm going to be heavily wrapping later. So I was introduced, Brian Douglas, developer advocate at GitHub. GitHub, if you don't know GitHub, congratulations. If you made it this far, if you're a developer, but it's a place for developers to collaborate. It's a pretty awesome tool. Highly recommend sign up, get an account. If you don't have one, I assume you probably do have one. But my job at GitHub, as a developer advocate, I like to joke and say that my job is Beyonce advocate because Beyonce is Queen Bee. Oop, going past the punchline, but she's Queen Bee. Beyonce has a very big following. She came out a new what do you call it? It's not a rock opera, but anyway, on Disney Plus, she has a music video along. I'm blanking on the actual name of these types of music videos where they're sort of similar to Lemonade. They had anyway, it's a long music video that's basically a movie. It's called Black is King. Definitely check it out. Highly recommend it. But Beyonce is a big deal. I'd like to say I'm a big deal. And my focus really, my first couple years at GitHub was around the GitHub GraphQL API. It's also the introduction and why I joined GitHub. It's because I spent a lot of time working with GitHub's GraphQL API because it was one of the first publicly consumable GraphQL APIs to be able to be leveraged. GitHub is a very large product. There's a lot of different users. Today, there's 50 million users. So they have a lot of different types of problems that they have to sort of solve with GraphQL. So if you're interested in like tinkering GraphQL, maybe you're at this conference and you're just sort of experimenting, I would recommend leverage your GitHub account you just created today and sign in and then test it out inside the GraphQL Explorer, which is linked in documentation. Around the time, this is before I joined GitHub as an employee, I actually had Kyle Daigle on, who's our director. He's one of the directors of engineering now. At the time, he was like senior manager. Talk about the actual intention to use GraphQL. And there are a lot of stuff that I'll talk about in the future slides about why GitHub chose GraphQL as their publicly facing API. And a couple of the things that I'm going to cover actually got covered a year ago at GraphQL Conf in Europe. And if you don't know Dan Schaefer, he's one of the co-creators of GraphQL. He actually gave a talk about GraphQL before GraphQL. And basically goes through like what GraphQL looked like up until the run to when GitHub, the pre-alpha version of GraphQL and GitHub adopted that. It's like around that same time. He also made a mention of all these different things that GraphQL wasn't solving a year ago, which is like implementing authentication. There's no real good story around that. How do you handle caching? This is a big one for me because this is something that sort of slowed me down in my GraphQL exploration. It's not being able to cache my results. Now things like Relay and Apollo, they do this out of the box. It makes it a lot easier for you. Also server efficiency, being able to, yes, GraphQL is great because you can ask for the data you want, but sometimes that data cannot be efficient. So I'll talk about that briefly as well. And then also rate limiting is a big deal for GitHub because we have a public API and we have so many people integrating with GitHub's API as part of our platform. You think of like Netlify or Vercel or all the Circle CI as well. Like they'll integrate with GitHub's platform. And so there's a big load against the API that we have to sort of make sure we taper down and sort of keep consistent. I won't talk about everything because I think my coworker Dinah, she gave a talk again last year after GraphQL Conf, sort of summarizing her experiences from Dan's talk and explaining how GitHub solved all those problems with our API. So I highly recommend check out that YouTube video that's right there. Again, my slides I'll tweet out if you have to find this later on, but about empowering GraphQL through our API. So my whole talk is going to be consuming the API. Like I don't ever work on the GraphQL API directly because I have way too many coworkers that do that already. So what I do is I ask them to do it for me. So if I have a feature or something like that, I just say, hey, can we get this exposed in the API, or can we figure out how this works? So I don't actually touch the API directly. I just want to make that clear. But what I do want to talk about is how I persisted GraphQL and GraphQL queries. So persisted GraphQL queries is something that I wasn't aware of until roughly like 9 months ago. It's something that the community has sort of developed and sort of figured out a solution for it. And it's a way for us to basically take all those things that I had on the previous slides and take them into account, but make it a little more approachable. And I do want to point out that Swix, so Swix.io, Swix is actually, he's on the AWS Amplify team. So they're actually making it a lot more approachable to not only do GraphQL and start the GraphQL project, but also integrate with the AWS console and platform pretty easily. So check out Swix's blog. Swix is like, he's kind of killing it with his blog. He's been posting a new post every single day for quite some time. So I'm a big fan of watching his blog because he just sort of gives a lot of really good context for things that I'm interested in and just deep dives into it. So give him a follow or use an RSS feed reader. I don't even use one anymore. RIP Google Reader. But I bring up Swix's blog post because if I could he explained it perfectly, persisted GraphQL, what it really means. And like GraphQL is kind of like you have a menu at a restaurant or a diner, and you have all these other things that you just want to look at. It's like walking in the diner and saying, I'll have the usual. Like if you already know what you're going to need every single time, it's better to have that cached version, that persisted version available to you. So, and that's what I'm doing in some of my apps that I'll talk about. But if I could explain it, persistent GraphQL, it creates a smaller signature, it reduces bandwidth and utilization on loading times, client loading times, which I'll get into. But I want to talk about how I discovered persistent queries, which is through my Twitch account. So plug. I live stream, actually, it was just on a live stream roughly about 30 minutes ago. And I live stream every Tuesday and Fridays and on Twitch, just around code, and talk about GraphQL, talk about GitHub Actions as well. If you want to kind of ask me questions, find me. That's definitely the place to do it. But the way to support my Twitch channel and sort of all the ideas that I want to actually work with, I created a website, which is called bdougie.live. So again, plug, feel free to follow that. But the way this site is run, it's actually built on top of a couple different technologies. So it's actually powered by GitHub, GitHub's API. And I'll talk about that in the next slide, but it's powered with OneGraph. OneGraph is a really cool tool that everybody here should probably know about and sort of try out. It's also powered by Relay. So Relay is like a consumer of GraphQL APIs. It gives you a lot of cool out-of-the-box stuff in their library. And it gives me a way for me to sample GraphQL. So I'm sampling GitHub's API, and I'm able to build an entire product really in a project on top of that. And I had mentioned that it's built on a GitHub repo. So if you notice that my repo organization, it's my name, bdougie/live. The repo is actually called live. So I felt like that was good marketing, bw.live, which is a actual usable TLD. But if you notice here, I've got these two issues that have this publish flag on it. And the way it works is that any issues that have publish labeled on the issue, it then shows itself on the actual website. So what I do is similar to like blog post, I have these quote unquote blog posts where I type out exactly what I'm working on live streaming. And that's how the site sort of works. And the cool thing about this is that I can also add reactions. So instead of having I can have comments as well, with comments are GitHub issue comments, also GitHub issue reactions. So you can see I have 2 thumbs up on my Twitch bot, and you can see I have 2 thumbs up here on this Twitch bot issue. So that's how this works. So I'm basically taking BW Live. It leverages an auth access to cache data from the GitHub API to be able to present that data. And the cool thing about this is that data is presented through my GitHub token. And the way I can do reactions is I can hand over that token to whoever logs in and wants to do that reaction. They then pass the token to them, that account. So you have to have a GitHub account to be able to do a reaction on my site. And then that reaction just adds a reaction directly on that issue. And this is roughly how I'm doing it. So what we're looking at here, this is actually the setup of a persisted query. It looks very much like a fetch request. Actually, this looks like GraphQL. This is not a fetch request. I'll show you in a couple slides what that actually looks like when I'm consuming it. But this is GraphQL right here. I do have some configuration variables, which unfortunately in the syntax highlighting, when I grab this, it actually looks like it's commented out, but you can see the word on line 3, persisted query configuration. And that's just where I'm passing in the token, where I can do that sort of swapping of that token. The repository fixed variables, those are going to be just my name and then the repo name, which is live. So I'm using the same pattern in a couple different other projects, but this is the pattern I sort of approached doing it. And then you can see down on the spread, down on roughly like around line 9 or 10, you can see the ... Post repositories, and that's where my actual query lives. So my query is actually stored somewhere else, but just free imagination, I would have an expanded GraphQL query that's actually stored directly there. So similar to that menu concept, I'm having the usual. So every time someone goes into my site, they're just asking, can I have the usual? I had this highlighted. I didn't actually use that, but I'll just move on. So yeah, this is OneGraph. I highly recommend check it out. OneGraph kind of is the backbone to a lot of my exploratory GraphQL stuff. Not only is it powers my GitHub GraphQL interactions, it also has Twitch integrations for their API. So OneGraph is essentially that. And I'm going to talk about OneGraph a lot because I use them so heavily. I don't work for them, but you should definitely check them out for sure because they make a lot of things really easy for me, and I'm sure it'll make a lot easier for you as well. I also want to mention, I mentioned earlier that persisted queries are built into the spec and the API for Relay. So the way it works is I'm using React hooks because a lot of the code that you'll see in snippets of is React. Despite that, Relay can actually run with other front-end frameworks as well as mobile frameworks. Well, iOS and Android. Technically, I guess that would be a framework, but yeah. So I'm actually enabling caching through these React Relay hooks. So things like checking to see if I can use the preloaded query. If I already have the data, like my GitHub issues don't change very often. Actually, they hardly ever change. I haven't even added a new project to my streaming in probably 2 months because I just continue to just work on the same stuff. And so I'm just using preloaded data each time. And the only time I have to check to see if there's new data is someone actually adds a reaction. So feel free to go over there, add a reaction, and test it out either now or later today. Just open a new tab, keep me open, and then you can test it out. And the way I'm doing this is actually Relay has a compiler where I can take the data of all my queries and actually put them into, I'm using a script, which is persistquery.js, which I don't have time to go through details of how it works. I think it's pretty straightforward if you take a look at it. And I'm taking that schema and I'm actually persisting those queries and storing those within OneGraph. So again, this is I'll have the usual concept. Also, I know where the period should go. Just realized I messed that up. So yeah. So I'd say all this because the GraphQL API provides opportunity to find interactions based on solutions, not endpoints. So that's my biggest thing, sort of like why I like GraphQL over using like a REST API is because my approach into REST is I always have like, for this one example that I use, which is grab all contributors across one org, it's gonna actually be expensive call. It's gonna be like, depending on how many repos you have, it could be that many rest endpoints you have to hit just to get that one question answered. And with GraphQL, I can actually just have one query for that. And no, this is actually an expensive query. I can actually cache this and do it once and be okay with this. So that's this example. And sort of put your headspace in there into like what you would use the GraphQL API for. So this is an example of persisted query. This is what I was trying to show with the fetch request earlier when I was messing up. But the one thing I want to call out is the biggest difference of persisted queries is instead of passing in a query into the fetch request for GraphQL, you instead pass a document ID. So this is your persisting. So you actually take all the query data, the mutations, and you bundle it into a doc. And that doc ID is what you actually send back and forth. So this is, imagine sending the query that I had here for the entire org. This is an expensive query. I instead can just send a doc ID across the wire, and then wherever my query is persisted at, in my case, it's persisted in OneGraph. But you can store this in your own database on however you want to approach it. It's obviously going to be much more, it's not going to be as expensive because I'm just basically sending my 6 characters that you can see right there. The other cool thing about this is that it reduces the attack surface area. Now I work for GitHub, and a lot of the projects that I use end up using GraphQL. So we have a couple projects that we have right now. It's stars.github.com has a GraphQL API that's consuming from GitHub. Because there's a lot of people using that, I think within the first week we had 70,000 impressions on that. So like we have a lot of people looking at our stuff, and a lot of people looking for ways to break in and do nefarious things. So because of that, we want to be able to set that layer on where I don't want people to access the entire query and basically look at exactly what's happening and been sent over the wire to the API. Instead, I'm going to send just a document ID. So document ID is going to be pretty hard to sort of manipulate and figure out what to do with it. Because no data is being sent back and forth. No expansive data is being sent back and forth, just a document ID. So surface area has been significantly reduced and constricted to that. The other cool thing is that it provides better hooks in the GitHub API. And this is like the biggest thing that I look forward to when I build projects and sort of explain concepts and things like GitHub Actions on GitHub's API, is I'm always looking for better hooks. And no better person to talk about hooks than Puff Daddy. So I mentioned this because I didn't really actually go into detail about Tupac, but Tupac was actually shot in 1996, unfortunately. And his counterpart, who is like, I guess, East versus West rivalry, was actually Biggie Smalls. Definitely check out both of those people. They have great music and kind of music that's sort of gone through the ages of different generations, mainly just one generation at the moment, but we'll see. And what I'm getting at is that Tupac, he's like the king of sampling. He was the king of sampling. There's actually some better samplers, but we don't have to go back and forth about that. But he actually sampled a song after the death of Biggie, which is from The Police, which is completely different genre. I guess it would be like Euro pop. I don't know what the actual genre is, but anyway, The Police had this Every Breath You Take song, and he actually took that sample and created that I'll Be Missing You song, which was kind of a big deal, at least when I was getting into Napster. So I would basically just say that rap changed forever at this point, because what was old is now new, and wrapping APIs is now a thing that people are consistently doing, and sort of co-locating APIs together and actually separating your concerns through your API. I think the idea of having a monolith for every new project has kind of slowed down a bit. There are problems with not having a monolith, but there are also problems with the monolith. So I say that because rap became cool again, and also expanded in the 2000s, expanded across different people groups and different taste and flavors. So I said even Will Smith came back. The Fresh Prince came back to rap at that time. So I say that because when GraphQL came out, I was really excited about the concept and the process of configuring GraphQL APIs and leveraging data and asking for the data I wanted. So I did that. And I did that on GitHub's API because I always wanted to contribute to open source projects, but I just never had like a good platform or a good way to be consistent about it. because I find that open source is pretty challenging to stay consistent with, but also just to discover new things. But the irony is that GitHub is the place to discover open source. So the project that I'm going to talk about is actually, yeah, anyway, I don't know where to start. And the project that I'm going to talk about actually I thought of the name of it from Gucci Mane. And Gucci Mane is a godfather of trap music. He's based in Atlanta. He's also has this quote that's attributed to him, which is, if you don't got sauce, then you lost. And I had mentioned this. I also mentioned that he's a big fan of sampling too as well. So if you ever heard of this Minnie Riperton song, "Loving You is easy because you're beautiful." Yeah, so he basically took that song and like completely revamped it and something completely different, which kind of just blows my mind when I listen to it. But I say that because I ended up making this project to manage my open source contributions, and I ended up calling it open sauce because based on the quote, if you lost in the sauce, or if you don't got sauce, then you lost. And it's sort of this, I can summarize, it was a way for me to save and take notes and rediscover projects for later. And the way I did this is I wrapped the GitHub API with OneGraph, and I'm able to, well, OneGraph did it for me. I just sort of logged in and it worked, and its powers a React app. So I make this joke. I took a chance on wrappers. And what's really cool about this, the whole integration, the wrapping is pretty straightforward through this tool called Auth Guardian. So OneGraph created this sort of auth feature within their feature suite, and I'm able to have access to this. So here I have I have open sauce. On the left, it's actually open sauce's dashboard, and on the right, it's like another GitHub repo. So I'm a big fan of using GitHub repos to store data. All the content on the left is actually one-to-one recreation for GitHub issues. If you do want to check it out, it does live on opensauce.pizza. I do have to speed up a little bit because I have quite a few more slides, and I'm going to sort of skip up over a couple of different things, but check out open sauce. One thing that comes up a lot in my interactions with the GitHub API is actually rate limiting. It's actually a problem for a lot of different people. So GitHub has had this for a while, but we have this point system to be able to quantify how expensive expensive queries are on the GraphQL API. You start with 5,000, and basically each query, like the all contributors queries, roughly are like around 30-ish points. So it is expensive because I can only do that so many times in the day, or within the hour is when it actually resets. But I had this one issue with open sauce, and the way I was logging in is I was just asking for too much data. This is actually an issue that was opened up and sort of made me discover this back in June from Joe. And I was giving unfiltered access to all GitHub's, all your users' GitHub info. So the way I approach this is actually I built a GitHub app, and I don't have time to go into detail about GitHub apps, but I just want to mention that the GitHub apps is basically give you a fine-grained permission to you only have access to the repo that you install it on. So because OpenSauce.goals is the repo that gets created when you log in with OpenSauce, I can now only have access to that. The problem is, if I do it this way, then I don't get any access to any public data. So any open source data, I can't do it through this GitHub app. So the way I solved this is I took my repo query and I persisted it into a persisted query. And the way I leverage this is I use a GitHub OAuth app just to grab public data, which doesn't ask for any user permissions. And I'm doing it through a document ID. So I say this because I can now easily work with the GitHub GraphQL API. I have that sort of mindset. I can give access to my token and not worry about rate limiting because I can manage that from my persisted GraphQL query. So all the stuff I showed was open source. I highly recommend if you take a look at it, ask me questions, open issues, or just like bounce into my my Twitch stream, and I'm happy to answer questions there. I do have a Twitter account for open sauce where I tweet out a bunch of open source good first issues. My goal was actually to provide an accessible path for people to contribute to open source. So that's what that project is. I definitely didn't have time to go in the deep about everything about the project, but that's sort of the cliff notes. If you're interested in learning more about the GitHub API, I highly recommend checking out the GitHub community forum. There's a lot of answered questions there. You can solve your problems and your questions through either the API or actions. And then one more time, twitch.tv/bdougeo. Definitely check it out. I am happy to have more people show up and watch me live code. So with that being said, I'm bdougeo on Twitter, and you should see that on my screen. Thank you.
Thank you so much. That was so awesome and so engaging. We really appreciate it. It's always you brought up Tupac. I know Shruti in the comments was like, Tupac! And I remember when Tupac and Notorious B.I.G. were a thing, and then I miss those times. The good music coming from them.
Yeah, it feels like forever ago, but
It really does. And then it just feels like
Spotify.
yesterday,
Yeah. Watch the documentary. You go through a lot of all that history.
Yeah, I still remember that I'll Be Missing You song was like one of my favorite songs ever. And I remember watching that music video on, VH1 or MTV, whichever one it was.
Excellent.
Well, again, thank you so much. And I think it's amazing that you're doing Twitch streaming and all those other things as well. We're super excited to have you. So, again, everyone feel free to follow Brian on all the channels and find him on Twitch and Twitter and all the other cool places. Thank you so much for joining us.
Yeah, it's a pleasure. I'll see everybody around.
See you soon. Awesome. So next up, we are going to have Allison, and Allison's going to be joining us on the 30 mark. We're going to be doing a quick live sound check in just a little bit, but feel free to take a restroom break, grab either afternoon snack, midnight snack, dinner, whatever it is, and we'll see you back here in just 15 minutes. Hi, Allison. We're doing a live sound check, so I've added you to the live stream, but just wanted to make sure that your audio works and that you can share your slides with no issue.
Great.
Looks like I can. That's a good start.
Yes. And then I am cutting this so stupidly close. I'm actually, so I went ahead and pre-recorded because I am fairly lousy at live speaking.
Yeah.
And also I wanted to make sure that I got a lot of information in the right amount of time.
Mm-hmm.
So it is building. I think we're going to make it like right on time.
Okay. Sounds good. Awesome. And then if you'll see in StreamYard that there's a private chat and then there's a comments. So the comments are the live YouTube chats. And then the private chat is anything if you need to talk to myself. So do you need to share your screen or anything and see if it works, or are you good?
So I can bring up a previous video. Oops, that's not what I wanted to do. God, gosh darn it. Okay. So I've opened that, StreamYard, share screen. So I'm going to do this. Share screen, application window, this one. It is not letting me share audio. Except for Chrome tab.
I also don't see, I don't know if you've actually shared, but it doesn't look like it's sharing yet.
Let me try sharing this and see what it does, but let me know if you can hear anything.
Okay, I'm going to add it to the stream real quick. Hold on a second. Okay, I've gone ahead and added to the stream. So if you press play and there's audio, then it should give us all the audio.
It's playing audio, but you're not hearing anything, are you?
No.
Okay. Well,
it might work if you share and then you take your headphones off, and then maybe we hear it through your, it's playing with your stuff. If that makes sense.
Okay, let's try this.
Okay, I'm adding it to the screen, but now I cannot hear you. No, can't hear you. Hey, Shruti, added you to the screen. Nope, still can't hear you. Are you on your computer? Like, is there a speaker in your computer? Nope, can't hear you.
Might need to allow notification mic access.
Hmm. If you use a Chrome tab to play the video, then you can add the audio, says Jeff. Thanks, Jeff. Even works if you're using a local file, he said. So I guess maybe trying to play it in a Chrome tab. We can't hear you though. I think you're just muted actually. It looks like you're just muted. Which would be terrible. I should have looked at that icon. There you go. Yeah, maybe you want to try it again and play it and maybe we can hear you this time.
To production,
Yep.
focusing on performance.
Yeah. We can hear you. That was the whole problem. It was the mute button. My bad. My bad for not noticing.
All right, I'm gonna do this without the headphones then. That's fine. Okay.
Well,
And,
I think you're all set.
all right, so is my face gonna be showing while
Your face is showing, yes. Your face is showing right now.
it's gonna be showing during the pre-recorded stuff?
Well, we can turn off your video if you like.
Yeah, if we can like start off without me and then or my video, and then we can like turn it on afterwards for like the Q&A and the actual discussion.
Okay, yeah, we can do that.
Thank you.
Sure.
I'm still new to this whole like lots and lots of presentations per week thing. I'm
Well, sounds like you have an amazing system down. So, okay, I think we're all set for the sound check. So I'm going to let us hang out, and we will be back in just about 4 minutes. So see you all in 4 minutes. Okay, and we are back with Allison and Shruti. So we're very excited for this amazing talk that's about to happen, but I'm going to go ahead and let Shruti take it from here.
Hey, welcome back, everybody. It is really hot here in SF Bay area.
Oh man.
Why is it August? I can't. But anyways, I hope you're staying hydrated. I hope you're staying safe wherever you are.
I think the worst part about the Bay Area is that it's getting hotter every year, right? But in California, it's like nobody has AC. I mean, you know, there is AC, but not
Exactly. Exactly. And my apartment is an oven right now. Ugh.
Oh man. Yeah, I lived in Oakland for a while, and yes, the no AC thing. And August, that was the month where it totally mattered. And it was not.
Exactly. Oh my God, it's really hot today. But actually, I really like Brian's talk, and I really like the hip hop section of the talk, and that kind of inspired me for a dev joke. So I'm going to ask a question, music based. What do you call a computer that sings? And chat can answer as well.
Yes. A computer that sings. More musically talented than me?
That's a good one.
I like it. Does chat have any guesses?
I don't see any comments yet. But I love that the folks watching got the last joke. That was nice.
Oh yeah, Igor? Yeah.
And the other great part is if you follow Shruti, I just retweeted your dev joke. If you follow Shruti on Twitter, you can actually get some dev jokes as well.
Constant feed of dev jokes, constantly. That's all I talk about.
I like it. So what's been your favorite
Fiona Apple
participation bit so far today? It's been a long day. I can't believe people have actually like just stuck with us all the way until the end of the day on Friday.
I know. Some commitment.
I think my favorite part so far has been the panels because it's just so great to see friends. I'm pretty, I know people who know me don't think I'm introverted, but I'm pretty, antisocial / introverted. At least my husband tells me that. My husband tells me I'm antisocial.
I'm so surprised to hear that. No. You can't be. That's a lie.
Yeah. So I was like actually really excited when everything started happening, and we started going into this like shutdown mode. And now I'm like, oh man, I miss my friends. I miss going to conferences. Like I totally miss that. I miss wearing my shoes.
I know. I miss dressing up and going to conferences and work outside.
Now when I go shopping, I don't even know what to buy, right? Because I'm online. I'm like, wow, this dress is so pretty, but like,
when am I gonna wear it?
Exactly. When am I gonna wear it again? So when am I going to sell all my shoes?
But that is not stopping me from shopping though. I'm spending so much money every single month on clothes that I should be wearing at home. I may have a problem.
It's the boredom, right? Like the boredom of just all you can do is online shop or take out.
Exactly.
It's ridiculous.
Yeah, we'd love to hear in chat, by the way, your favorite purchases. So if you have any purchases that you've made that you're either proud of or, not so proud of, we're super, super curious.
All right.
Back to the question, which was, what do you call a computer that sings? Somebody said beep, and I really like it.
Yeah.
And a computer that sings is a Dell. Get it?
Oh, that was good. Adele.
I like that a lot. Okay.
With that, Allison, are you ready?
Yes. So
All right,
are we
over
good to
to
go?
Allison, who's going to be. Say that again?
Good to go?
Yes. Over to Allison, who's going to be talking about data federation with GraphQL for the enterprise.
Hi, it's nice to be here, and thank you all for sticking with us on a Friday afternoon. My name is Allison Kunz, and I'm a solutions engineer here at Hasura. Today, we're going to look at the challenges of data federation with GraphQL for the enterprise, and how the Hasura GraphQL engine offers a unique framework for GraphQL services that can overcome those challenges. We'll start with a quick review of GraphQL and how the Hasura GraphQL engine works. Then, we'll look at the challenges of GraphQL for enterprise, what a good solution would look like, and how many popular options haven't quite met those goals. We'll look at a better path to federation and all the key details about how it works. Finally, we'll have a conversation with Q&A after the presentation and demos. Let's start by taking half a step back. Why are we even talking about GraphQL? GraphQL is an API specification, just like REST or SOAP. It was first created by Facebook, open sourced in 2015, and is now guided by the independent GraphQL Foundation. It's data source agnostic and increasingly popular, with several mature server frameworks and clients supported by an enthusiastic community. Why the enthusiasm? GraphQL set out to address a number of structural changes with REST APIs, especially with highly interconnected data and mobile applications. A GraphQL service starts off with a schema, a typed mapping of your data objects describing their fields and relationships to other types. Based on this schema, GraphQL can offer introspection and validation to power amazing developer tools like automated documentation and auto-suggest while writing queries. Then, GraphQL services allow you to customize and shape the data response without supporting a multitude of endpoints and versions. This cuts down on data transformations that have to be done on the front end, making developers happy and more productive, and eliminates overfetching of data, which means less data transferred over the wire and happier customers. Finally, GraphQL frameworks are generally mature enough to have automated a vast amount of API development and maintenance work. It's reduced a lot of friction on both the front end and back end, supporting modern data-driven services. Here are resources for learning more, and a demo GraphQL API with Star Wars data published by the GraphQL Foundation. Now that we want UX and DX improvements from GraphQL, how do we go about setting up a service? The Hasura GraphQL engine is an open source solution that provides a full-featured API out of the box, instantly, for any Postgres database. It also provides a data federation platform to bring together data from all your different sources, REST, GraphQL, serverless logic, etc. With Hasura, you can pull all of your data sources together into a seamless GraphQL API. It's worth looking at how Hasura works under the hood, since this helps explain how it can provide great performance and extensibility. Let's look at a simple query, listing artists and their albums. A very naive approach to providing the data for this query is to query the database for the list of artists, and then querying again for the list of albums for each of those artists. If there are n artists, there are 1 plus n total database requests to resolve this query, hence the n+1 problem. The first popular approach to solving this problem was to implement a data loader service that could batch the n album requests together into a single request. This was a massive improvement and commonly used. However, if we start to look at queries with growing complexity, we can see that this problem presents a real challenge to most real-world applications. The naive approach gets exponentially expensive as queries get more and more nested. And the data loader approach reduces to linear growth, but is still not a satisfactory solution. From a DBA perspective, the query that we have looks extremely simple. Your SQL database owner would look at the GraphQL query performance and wonder why on earth you thought GraphQL would ever be a good idea. And they'd have a point, right? So let's think about what it would take from a SQL perspective to provide the data for that query. It's not a complicated query, and SQL already has ways to optimize the execution and response. So what would it take to have this SQL query instead? That's exactly what the Hasura GraphQL engine does, and why its performance is so blazing fast. The query is parsed and compiled into a SQL statement, which Postgres can handle easily with its decades of experience in optimizations. Perfect. The compiler approach lends itself to other interesting opportunities as well. Hasura built in an authorization engine that can apply session variables and permissions policies to queries even before they hit the database, securing your data at the service level. Another major challenge for GraphQL services is how to architect subscriptions for speed and scalability. Again, with the compiler approach, we can apply a batching trick at the AST level to take care of many subscription connections with a single SQL statement. I'll provide a link to more detailed architecture information and benchmarks at the end of the talk. It's really interesting. The Hasura GraphQL engine has access to two important parts of this process between GraphQL query and SQL execution. First, there is the compilation process we just talked about, which we can here lump together under the Hasura umbrella. Then, Hasura can also instruct the Postgres instance to use prepared statements, which captures the work done by Postgres to convert a SQL statement from Hasura into an actual execution plan. This results in an incredible boost of performance at scale. So now that we want to bring GraphQL into our tech stack, let's take a look at how that starts to get challenging as applications and teams get larger and more complex. To give a little context, we're going to take a look at a very common component of e-commerce applications, the shopping cart. We're going to consider the data required by this component and the work involved to provide it. Let's break it down. The single component actually incorporates data from a variety of sources. Product, the information about the item itself, like name and manufacturer. Inventory, lets us know if the item is available, or perhaps warns us if only a few are left. Charges, calculations as payment. And order, the overall information about the cart items and checkout status. These data sources may not be co-located in a single database, or even managed by the same teams. For example, a company might have separate divisions for handling merchandise and orders. They may also use third-party services to help with calculating sales tax according to buyer location. Zooming out, we can see the context at the corporate level is even more complex. These data sources can have a wide range of data structures and API frameworks. We should also keep in mind the corporate divisions and teams. Communication between dozens of teams working from separate angles can be extremely difficult. Finally, we want to map out the different combinations of these data sources used by different applications. Even with very different stakeholders, there can be a lot of overlap. So what's the goal here? What needs to be true for a multinational megacorp to get the most out of an investment in GraphQL? First, independence is key. GraphQL services need to minimize the amount of communication overhead and complex dependencies. Taking a page from the idea of microservices, data sources should also not need to know about other data sources or what's happening downstream. The architecture needs to be streamlined to reduce risk and tedious engineering work. Changes and additions need to be relatively straightforward. And security needs to be both strong and flexible according to the use case. What are the common solutions that companies have been working with? Similar to what we just talked about in the previous section, a custom implementation of a GraphQL server would provide complete control, but also require solving hard problems from scratch. We've seen this before with the naive approach to GraphQL, and it's not much fun. We can retain and reuse a lot of the optimizations from different data sources with the backend for frontend or BFF approach. This removes a lot of the most tedious work, but the most difficult challenges, such as scalability, are still there. To solve these problems, it's tempting to double down and GraphQL all the things. Unfortunately, this is still a lot of work to build and maintain, now with dependency help. We've done a lot of work, but it doesn't feel like a satisfying solution. The application developer experience is better, but only at the expense of data services teams. We still haven't achieved any of our original goals or saved any time or money. Again, let's see if we can take a different approach. We can learn a lot from the previous options. We don't want to have to rewrite every data service from scratch. GraphQL wrappers let us keep those services, but at the expense of performance and scalability. We also want to keep everything as independent from neighboring or downstream services as possible. Let's federate the data sources rather than federating at the API level. Let's connect as directly to data sources as possible, mimicking the approach we took earlier with Postgres. We can treat everything as data models, integrating with them as they are. And we can put the relationship and security configurations back on the GraphQL server, not affecting the upstream services themselves. And that's what the Hasura GraphQL engine does. We have a declaratively configured server. Think like nginx.conf. Declarative data wrappers that map to each of our data sources. Some of them are provided by Hasura itself, like Postgres and remote joins, and others are simple handlers that we can provide ourselves. As we saw just a few minutes ago, that allows amazing optimizations that weren't possible before. Let's look at an example. Say we have a music application and we built a recommendations service for it using machine learning. It's now super simple to bring in that REST API. We just need to give Hasura the data model, a handler function, and a few parameters. And then it's incorporated seamlessly into our GraphQL service. At Hasura, we call these actions. Here's what that handler function would generally look like. We just need to provide the endpoint. It can be deployed as part of a server or a serverless function. It also doesn't matter what language we're using or where it's hosted. We can continue to use our favorite languages and services. So what have we got for making these declarative data models? Hasura offers two types: remote schemas for GraphQL services and actions for everything else. Actions, like the example we saw just now, are basically schema extensions with custom resolvers. They give us amazing superpowers to add business logic or transformations to our data. We can also bring in REST or anything else custom third-party services. All we need is that function handler. Remote schemas are even easier. Hasura will introspect the GraphQL schema and do the handler work for you. You can instantly include outside GraphQL services, such as a Hasura instance from a different division, or a SaaS like GraphCMS. Check out GraphQL Mesh as a tool for getting the ease of remote schemas with non-GraphQL sources. All right, so now that we know how everything works in theory, let's actually dive into a demo of data federation with Hasura Cloud. Welcome to your project's dashboard on Hasura Cloud. To create a new project with an existing Postgres database, all we need is the connection string. Depending on your Postgres setup, you may need to whitelist the Hasura Cloud IP address provided. You can also create a project with a new free tier Heroku Postgres instance, automatically provisioned for you with your own Heroku credentials. You can upgrade or manage this Postgres instance via Heroku. Cool. All set. This might take a while to initialize. So yeah, here we have a fresh Hasura project, no data. We could choose to use the Relay API if we want. But not much fun without data. So let's go back and look at a different project that I have. Here's the sandbox project I have with data federation. Let's start with the data tab. This is a music application with playlists that people can review and get more suggestions on what playlists to listen to next. These tables are in a Postgres instance on Heroku. Going back to the Explorer, we can see that there are even more types of data available than what we had in Postgres. These items are assets are actually from a remote schema, a GraphCMS instance where an item is a single review. And an asset is an image. We can access these types just like we can music or album from Postgres. Let's see how it works. We have a number of options for adding a remote schema. Let's take a look at the GraphCMS one we've already made. We have the GraphQL endpoint and the authorization header. That's all we needed to connect a new data source. Let's see the editor. Note that we can forward the headers from the original request and include new ones from static values or environment variables. Since this is a review of the playlist, I've added a remote relationship to the playlist. I've specified the remote schema. I've configured item where ID is equal to the review ID. From the rep. And if we go into the graphical tab, playlists, reviews, and then we have our reviews. So let's also take a look at our action, like we saw before. Suggested playlists. Again, we just need the definitions, the handler. We can forward the client headers, so we don't have to specify the user ID in the query. We can let that be handled by the header. And we can also add a machine learning service secret key from an environment variable to help keep things secure. We add a relationship. So we have object and array relationships. So one-to-one or one-to-many. We can name the relationship. We can specify the schema and the table that it's referencing. And we take from playlists in this request, it goes to suggestions on the playlists table. All right. So that's the demo. Any questions?
Thank you so much. Yeah, if anybody has any questions at all, feel free to post them in the YouTube comments. And if not, Allison, where can we find you for more information?
Yeah, so, oh, we have a question. See data for relational tables. Yeah, I hear you on that one. So there's a couple of options. One is getting the Postgres like terminal command for taking in CSV data and putting it into a database. It's manual, but it's fast. And the other one is if you have a database that you want to like clone or play with, a SQL dump is super handy. Otherwise, I mean, yeah, I think the fastest way that I know of is just getting a CSV with like Faker QL or something like that, and then putting it in with that command line. But that you do have to do that per table, and that is kind of a pain in the butt. Sorry about that. We do have a way of doing seed migrations. The documentation isn't super helpful. If you want to go onto Discord next week, ask around, and hopefully I can get a better answer to you there. So for using Hasura like you would maybe Federation, like or Apollo Federation. I mean, only the data that the service would need, right? So as we saw with like the mapping of all the different tables, we had the different application and the GraphQL that would need a GraphQL service each. And not all of that data needed to be accessible by all of those applications. So for a Hasura instance, if it only needed a subset, then you could only route those through that with a high level of security. As a you wouldn't need all of them in like a monolith. When a friend of different data sources all needed to kind of know about each other. In terms of Hasura Cloud, with its pro features, if you didn't want to use Hasura Cloud with Hasura Pro services monitoring the metadata and the logs and doing the analytics, we do have the enterprise version, which is self-hosted, which means that all of that data, like you're still getting the benefits of Pro, but Hasura is not accessing any of it. It's all of your own self-managed instances. All right. If that answered the question, great. If not, definitely continue to ask the question so that I get to the right answer for you. And then properly defining different APIs using different environments. This should be resolved. Definitely ping us on Discord or flag an issue in GitHub. Those are probably the best ways of going about troubleshooting any potential bugs or anything that you've seen. I haven't encountered that particular issue, but if you have, then we definitely want to hear about it and see what we can do.
Cool. Well, thank you again so much, Allison. We really enjoyed having you, of course. And
thank you.
Yes, and you can find Allison on the Hasura Discord or on the internet, so feel free to ping her there. Next up, we have Sergey, and we are going to be doing a quick sound check in just a little bit, but you have 15 minutes to go take a bathroom break, get some food, whatever you need to do, and we'll see you back here on the 15 mark. See you soon. Hi, Sergey. How are you doing?
I'm doing great. How are you?
Great. We are live, and so we're doing a live sound check here. Your audio is a little bit quiet.
Okay.
No, it's fine. It's fine. You're good. You're good.
Good?
Yes.
Okay.
It was me. All right. Do you want to go
All right.
ahead and see if you can share your screen and see if there's any issues there?
Yeah, let me try that.
Great.
Share screen.
Let me add your screen really quickly. Okay, there we go.
Okay.
Is that all?
Yeah, that's good. Yeah.
Lovely, wonderful. I'm going to go ahead and remove that really quickly. And I'll remove you from the screen. We'll be starting in just about 10 minutes. There's a private chat and also a YouTube chat called comments. So private chat if you need to talk to us. And then comments, you can see everybody chatting on YouTube. So I'll remove you from the stream and we'll see you in just a second.
Yeah, sounds good.
All right, thanks. Okay, welcome back, everybody. Let me go ahead and add Shruti and Sergey to the screen. And I'm going to go ahead and let Shruti introduce our last speaker.
Hey, welcome back, everybody. And thank you for sticking around. I know it's been a long day, so I really appreciate, and we all really appreciate you being here. So everybody who's here for you, applause. My own audience. So I want to introduce our last speaker here, Sergey, who's going to be talking about pushing your React and GraphQL testing further. Sergey is a senior software engineer at PayPal, and he's the member of PayPal's web checkout team. Last 4 years, Sergey spent time building core checkout experiences at PayPal. An interesting fact about Sergey is that he began his career as a video game developer in Ukraine while in college. Sergey says he had no idea that years later he would play a role in one of the most successful payment companies in Silicon Valley in the world. So Sergey is going to be talking about an interesting topic that always arises a lot of questions, and that is testing GraphQL and React together. The floor is yours, Sergey.
All right. So hello, everyone. My name is Sergey, and I'm super excited to be talking to you virtually. So I hope you're all healthy and doing well. And I'm pleased to be talking with you about pushing your React plus GraphQL testing further. So a little bit about myself. I work at PayPal in web checkout team, building new checkout experiences in checkout web platform itself. And by the way, this is my first, public talk on the external conference. So let's go ahead and get into this. So this is what we're gonna be covering today. So to begin with, I'm very concerned with the topic of an effective application testing. And so I will be talking about testing React applications which are using GraphQL. So I will walk you through, a story about checkout testing evolution and our next-gen checkout app that many of you probably, already used when you choose PayPal at online shops. Then I will talk about the solution that we came up with as an outcome of this journey. I really hope by sharing, our experience, you will be able to improve testing of your, own applications. So let me give you a little bit of a context. So our checkout app is a React application, which uses Apollo as a GraphQL client. And on the server, we have our GraphQL layer as a node app. Nothing unusual, right? But the problem, is that checkout itself is very complicated and involved. There are hundreds of different combinations of interface and user flows, depending on the country, user settings, type of integration, experiments, and so on. So reproducing these user flows is a challenge. As a result, the development of new features or fixing bugs slows down a lot. And many of the flows requires like reading long instructions or creating user accounts or finding instruments. And at the end, downstreams might be in the good mood to give you the data you need. Developers, of course, are no stranger to such things. But what about designers or product managers? How are they supposed to first reproduce all these user flows, and second, keep in the head all the different combinations of the UI? Another example, let's say developer has finished working on a feature or a bug, and the product manager wants to do some verification. It's tempting to say, could you please go read the instructions which I can send to you so you can reproduce the flow yourself? And so pretty much developers end up making screenshots or videos or showing demos of their new features they built or bugs they fixed. And I consider this is not efficient. So what are checkout testing challenges? As you may have guessed, all this leads to certain difficulties when testing. Effectively testing such a large number of user flows is not an easy task, given that we do not have a separate testing team. We also don't want to, to depend on full-fledged end-to-end tests for every single user flow because, of various reasons, such as it's kind of slow. There is instability factor in end-to-end tests. And at the end of the day, it's inefficient and not scalable to run end-to-end tests or testing manually changes after every commit or pull request. So let me walk you through the evolution of testing in our project. So let's take a look at iteration number 1. So initially, we had tests written using the enzyme testing library. So the test would render a connected GraphQL component that is wrapped by an Apollo mock provider. So Apollo mock provider allows us to provide mocks for GraphQL requests. So we have to basically write mocks for all the queries used in our component and its child components. Also, this component may require props to be passed. After we have rendered the component, we will go through the assertions in which we will have some checks. For example, whether a particular component with the name X has been rendered or not. So, what's wrong with this approach? Can you guess? First, testing components in isolation is not very effective, since we do not know whether another part of the system with which this component may interact will behave correctly. And second, testing implementation details is kind of evil. So here, we're kind of checking our components by name, which is not very good. And the test can simply fail if the component's name changes. Let me show you some code. So this is sample test. We have our query mock here. It has some variables and some mock data, and then we're gonna render Apollo mock provider. We're gonna pass mocks. In this case, just one mock, and then we're gonna render our component with some props. And down below we have our assertions where we're gonna find whether some component with this name exists and being shown on the UI. And question is, does such a solution solve our problem? Obviously it doesn't. So we have to move on, and we moved on. So this is our next iteration. After thinking over the mistakes, we came to the next iteration. So we replaced the enzyme library with React testing library, which allows us to avoid testing implementation details. Instead of checking components by name, we strictly began to emulate the user behavior to test components in the same way as users would do in the browser. So for example, finding elements by labels or by text or by test IDs. But the problem of testing individual components in isolation is still there. So let me show you some code. So pretty much, this is the same mock that we had before. This is the same component and same Apollo mock provider, but now this is the difference. So now we're gonna basically check if elements exist based on some text that in these components. So we're gonna just check if payways text is there, and then if FI number 1 and the FI number 2 are there, and we're gonna click some link with some text. So this is the difference, and it it was a big deal. But does such a solution solve our entire problem? Obviously not. So we moved on, and this is iteration number 3. After thinking over the mistakes again, we came to the next iteration, and we started rendering several logically related components together. On the positive side, it should be noted that this allows us to test the features more fully when all the components involved in a particular feature are rendered together. On the negative side, as you can see from this diagram, the number of mocks has increased significantly because each component can have from 1 to several queries, for each of which you need to write your own mock. Another caveat, we're faced with a constant need to think about which components to pick for which feature and look up which queries are used in these components to provide appropriate mocks. As you would imagine, we kind of ended up with a ton of mocks we had to deal with and maintain. So let me jump into some code for this solution. So here we have mock for component number 1, and then we have another mock for component number 2, and then here we have a bunch of other mocks. We could have like 10, 20 different mocks here. And then we're going to render same Apollo mock provider. We're going to pass all these different mocks for each component. And we're going to render these components together. Down below in our assertions, we're going to do the same, basically, test our features how users would test in the browser. And the question is, does such a solution solve our entire problem? Obviously, no, not yet. So we moved on. So we started thinking about how can we improve our approach. So we've got a list of what we wanted to see in the solution. First, we have to start using real GraphQL schema for the mocks. Basically, move away from writing mocks for each query to writing mocks for GraphQL field resolvers used in the schema. Second, we wanted to stop thinking about which components to pick for each user flow. Basically, this can be solved by rendering like entire client app without knowing the details of how it's implemented under the hood. And third, the solution should support, running user flows not only in the browser-like environment, for example, JS DOM. If you're not familiar, JS DOM is used by default in Jest, but also in real browsers manually or in automated end-to-end tests by reusing our assertions. Also, the solution should make it possible for developers, designers, or product managers to launch user flows without much efforts and not going through long instructions. Speaking of metrics, we kind of wanted to reduce the time to build new features and fixing bugs. And the last one, that solution should enable mock-driven development mode, and let me explain that a little bit more. So why mock-driven development so important in the development of GraphQL React applications? Let me ask you a few questions. So how often have you had to start writing a feature when the API isn't ready yet? Imagine that the GraphQL scheme is already approved, but you cannot start development because you're waiting for the scheme to be implemented on the backend. Or how often do you try to test something and downstreams return temporary errors from stage servers, or stage servers are down completely? Or you were given a visual bug to fix, and in order to reproduce the bug, you need to spend a lot of efforts to create all the necessary user accounts, add credit cards, bank accounts, read huge instruction, and in the end, you may still not receive needed result because you simply forgot some additional step. So this is why we needed to have mock-driven development support built in. And also, I kind of really want to talk about advantage of using GraphQL schema mocks over writing mocks for individual requests. So problem with mocking individual requests are obvious. It involves huge amount of mock code that is difficult to maintain. Instead, when you mock your schema resolvers, you have little to no extra code. All you need to do is to implement default resolvers for a schema and then override the necessary resolvers in test cases. It's important to understand that when you use GraphQL schema mocks, you kind of start thinking not about the queries in your tests, which are kind of like implementation details, but about what data the schema should return for a particular user flow. And here we go. This is the solution, and we named it Apollo Case Manager. It's based on write once, run everywhere approach. It's powered by React Testing Library and Selenium WebDriver APIs. There is built-in browser integration. All mocks are based on the real GraphQL schema that is used on stage servers or production. And also, it allows development against mock APIs. Let's dive in, into how this tool works. So Apollo Case Manager is based on use cases which developers need to write. So use case is simply describes how user can interact with an app to accomplish a particular goal. So we can launch each use case manually in the browser through the use case viewer. It's pretty much a dashboard with a list of all the use cases in the project that can be launched manually by anyone. Something like a storybook, but the main difference is that dashboard is rendered right inside your application, similar to Redux DevTools. Each use case can also be run as a regular, just test directly from the terminal or CI, which will be using JS DOM instead of real browser. This mode is pretty much used to run quickly, all use cases after each commit or on CI and pull requests. And also, this use case can be run, as an end-to-end test that will launch a real browser, for example, Chrome or Safari or Firefox, basically any browser that is supported by Selenium WebDriver. One of the features of the end-to-end mode is that you can specify whether to use mocked GraphQL responses defined under use cases or trigger actual network requests. It's pretty powerful. As you may have guessed, use cases code is fully reusable between all these modes without any duplication. So roughly, speaking, if application is broken down into features, then each feature may have its own set of use cases. At this moment, we have many hundreds of different use cases in our checkout project. So let's check out the life cycle of the use case. So when we run a use case, first, we have to mock our schema. To do that, we create a default mock resolvers of our entire GraphQL schema, which we will be reusing across all the use cases, and then override only specific field resolvers in each use case. And next, use cases, they're gonna render entire React application based on the mocked schema. And then we're just gonna run assertions, if any. So let's take a look at some use cases example. Imagine you have some, you have some feature and you need to add a new use case. So the use cases folder is created in which we export an array of all the use cases, one of which is presented right here. So basically, this is an array, and this is the use case that we want to create for this specific feature. So each use case, it has it kind of consists of a title, with all the steps that's going to be needed, to run this use case. So we just have this title, and then next there is globals object. It's pretty much like a settings object that you could use, for example, to load your content based on the country or language. So it's like a settings object. And then next we have resolvers. And so this is the place where you can override default resolvers for your default schema. So imagine you have your schema and you kind of wrote resolvers for each individual field. So now you have default result for entire schema. And then you kind of okay, for this use case, all I need to do, I want to override just one field. So merchant may have 10 different fields, but I just want to override just one and set country being France. Every other values for all the other fields gonna come from default mock that we have for our schema. And second, we're gonna override checkout session. Right here, we're gonna override finding options resolver, and then we're gonna override credit offers. We wanna have one credit offer presented to the user. And so down below we have asserts. So this is the section which is powered by React testing library API. So in asserts, we're kind of making sure developers can only use asserts methods, which are encouraging better testing practices. So we are basically writing this asserts as we would usually do for end-to-end tests. So it's pretty much wait for some test IDs, click around, and then again select some options and stuff like this, right? And so you may, and basically the thing is, these asserts, they basically we're kind of reusing these asserts between regular integration test, which is which we're running using JS DOM. And these asserts are also, being reused in end-to-end tests. We don't need to duplicate, our test suite or anything like this. This is just you write it once, and then you can reuse these assets everywhere. And basically, you kind of you may have a question but how do you reuse this, assets, between integration tests and end-to-end tests? The API is different, right, in React Testing Library and Selenium WebDriver. And the answer is we implemented wrappers for each React Testing Library API methods in which, DOM queries are executed through Selenium WebDriver API. So when, these assets are being run for end-to-end tests, all these kind of methods of React Testing Library, it's gonna use Selenium WebDriver logic inside of these wrappers. So when the use case is launched in the form of end-to-end, the use case will open a real browser, and it will search DOM elements through WebDriver API instead of the standard DOM API that is available in React Testing Library. And there is another example. We have, again, feature, and we want to write some, again, new use case. We kind of define the title, step 1, step 2, step 3, and then in this case, this is like an add card use case. We have to click add card link. We have to fill out add card form, click save, and check some server-side validation errors. So we're gonna say, okay, this is some German user, and then we're gonna say, okay, this is default finding options we have, and this is the cool part. We can define and resolvers for mutations. So in this case, our mutation name is add card. And what we have to do, we have to throw some validation error. So we create some new error. We put something in the data. In this case, card CVV error code, and then we just throw this error for this in this resolver of this mutation. And then down below in the assets, we're just gonna check if error message showed up in the UI. So let me, give you some, demo here. So let's take a look. Let's see. Interesting. It doesn't show. Oh. Give me a sec. For some reason, it doesn't show my second editor that I have. Interesting. Okay.
You might have to share your second screen. Is it sharing a different screen? Do you just share that? Maybe if you.
So I can try to stop screen and then share it again. Okay, let me do it. Okay. Okay, awesome. So imagine we have some use case. This is that card use case. So what we're gonna do? We have some some resolvers right here. And so what we will also do? We're gonna run our application server. So we're gonna run our app on localhost. So in this use case, what we have resolvers. We kind of override some user stuff, and then we override some checkout session stuff, and then we override add card mutation. So what we're gonna do? We're gonna run this use case in different modes. We're gonna run this use case in the browser manually, and then we can run the same use case, but as an end-to-end test. So to run use case in the browser, what we have to do, we have to just add a mock mode equal 1 as a query param to the URL, and this should be basically how it works. So let me just open Okay, so this is our app. This is checkout, right? But the only difference is right now it's not talking to the network. It's based on the mocked GraphQL schema. So on the right side, we have this dashboard. So we have all these use cases available in our system and our project. So as you can see, we have list of different features on the left, and list of use cases for each feature on the right. So you see we have add card, add ban, credit offer, installments, rewards, ship to, and there are like hundreds of different features. And so we could basically say, okay, let's check split balance. Click split balance, and there are some use cases for split balance as well. So if I click split balance use case, it's going to like render split balance. So it kind of like refreshes the app, and it provides the mocked data for this split balance use case. So pretty much this is how managers or like designers or product managers or even devs are verifying the features manually. So you have right in front of you the dashboard. You can select any feature and just play around with it and just see how this UI is going to look like when you select some specific use case. So in this case, let's see add card, right? So we have add card. We have like a description. What we have to do in this use case. In that case, we're gonna load checkout, click add card link, enter submit card information, and then verify that funding instruments got updated with a new FI. So what we can do, we can click the button, then we can just fill that information right here, and it's not talking to the server at all. It's just basically based on mocks. So if I click continue, it's also basically making mutations which are not talking to the server, to the network. It's all based on the mocks. And so the same with split balance or with any feature, we can just play around with it, and we don't need to think about instructions. We don't need to authenticate users. We don't need to create users. It's basically way easier for anybody to run any use case, and make sure it's working, UI working, and your experiment, for example, working. We could also, force some locale. So let's say we want to test this use case, how it's going to look in Chinese. So we're going to select Chinese, and now our use case kind of loaded with a Chinese, locale with the language. And we can verify, some text is not working or something like this. So this is how you can run use case in the browser. And this is basically mock mode. This is, for us, this is mock-driven development. So when we write new features or we're fixing bugs, we basically will launch this mode, and we select use case, we fix the bugs or create new feature, and we're done. Also we could run this use case as an end-to-end test, right? So we're gonna just say yarn test. We're gonna select our test, and what's going to happen? It's going to open Firefox, and it's going to go through all the steps pretty much automatically. Yep. So basically, this is how it works, right? So it's the same use case is being reused in different environments, and also we could run this use case as a regular JS test, which uses JS DOM instead of the browser. So that's how we regularly run our use cases on CI or after each commit. So let me switch back to my presentation. Okay. So what are the conclusions we can draw here? as you can see, this solution goes outside of just being like a testing solution. Kind of improves many important metrics. In practice, we have noticed that time to write new features or fix bugs reduced significantly. Developers no longer depend on working backends, user authentication, internet connection, endless instructions how to reproduce checkout flows and so on. We kind of also noticed an increased confidence change in code. Apollo Case Manager allowed us to refactor code with confidence, making sure that we're not breaking anything and wasting time updating the tests, since use case is kind of like free from testing implementation details. It also allows us to work on a project in complete isolation from backends through mock-driven development mode. Also, use cases, they kind of serves us as a documentation. Use cases explain what's the expected behavior. So usually tests in comparison to any written documentation are always up to date, and that's great. Developers do not need to create videos or screenshots anymore to show how most checkout flows are working. They can just anyone, product or designer or anyone can just open mocked mode in the browser and just click some use case from the dashboard and see how UI behaves, how user flow works, without even asking developer to for long instructions and stuff like this. So the pretty much killer feature turned out to be the ability to launch use cases from the browser to be used by the developers, designers, or product managers, and this saves a huge amount of time for everyone. Question: is it open sourced? No, it's not yet, but it's under consideration. So yeah, I mean, thank you very much. I hope you had a wonderful time at this virtual conference. Stay healthy and stay happy. And yeah, check out this hiring and thanks you once again for listening.
Thank you so much. We are so excited to have had you, and that was a really amazing talk. And congratulations on your first public talk.
Thank you very much. Yeah.
So we're basically going to see you everywhere because you just can't get off that high now, right?
Yeah, I'm pretty pumped right now.
Yeah,
it was amazing to talk.
Amazing. Oh, we're so excited about that. So if you have any questions for Sergey, feel free to post it in the YouTube comments below. Again, everybody, thank you so much for having us. I'm going to go ahead and remove you, Sergey, from the chat. And, thank you so much, Shruti, for being our amazing MC. I couldn't have asked for anything better today.
Thank you for having me. I had so much fun. Also, this is the first time I am being an MC, so yeah, so many firsts.
Oh my God. And next time, Keynote. If anybody is looking for an amazing Keynote on GraphQL, feel free to hit up Shruti because she's just so amazing and she'll get everybody pumped up with dev jokes. All right, everybody. Well, don't forget that PayPal and Braintree are hiring. I think Mark said there's something like 88 open positions, and you can go to PayPal and look at the jobs section and search GraphQL as a topic, and then you'll see all the different jobs. It's really wonderful as well because there's so many different remote opportunities now, which is amazing because that wasn't the case before. And, if you care about PayPal or Braintree or wonder how they work, you can definitely hit up Shruti or Mark or any of some of the other amazing speakers that you saw here speak today. As well, I just wanted to thank, this.labs, which is my company, for supporting and, allowing me to do all the things I want to do, which is really exciting. I love it. And my amazing team. And, if you care about exciting things like this, feel free to visit us at graphql-meetup.com. And you'll see monthly meetups. Eve does a lot of live, basically training every month. And we also have amazing talks too. So other than that, we will see you next time. Thank you so much, Shruti.
Bye. Stay healthy.
Bye.